Hey guys, tonight we're diving into the history of the internet. You know, that thing you're probably watching this on right now, scrolling through while pretending to work, or binge watching at 2 a.m. when you should definitely be sleeping. But here's the thing, forget everything you think you know about how this digital universe came to be. This isn't some sanitized tech fairy tale. This is the real story, complete with government paranoia, academic rivalries, corporate backstabbing, and enough caffeine-fueled all-nighters to power a small city. Before you get too comfortable in that chair, hit that like button if you enjoy this kind of deep dive into the stories that shaped our world. And seriously, let me know in the comments where you're watching from, because by the end of this, you'll realize just how miraculous it is that your comment can travel around the globe in milliseconds. Now, dim the lights, maybe grab a snack. This is going to be a long journey, and let's jump into the most important story of the modern age. Trust me, you probably wouldn't last a day in the world we're about to explore. Picture this, it's 1957, and the world has just watched a beach ball-sized Soviet satellite named Sputnik casually orbit Earth while beeping like a cosmic smoke detector. Americans are staring at the sky, wondering if their morning coffee might be interrupted by incoming missiles, and President Eisenhower is having what we might politely call a strategic panic attack. But here's where our story gets interesting, and where your ability to binge watch cat videos at 3 a.m. was accidentally born. Because when governments get scared, they throw money at smart people, and smart people have a wonderful habit of solving problems in ways nobody expected. Enter DARPA, the Defense Advanced Research Projects Agency, America's official what if we tried something completely insane department. Think of them as the government's mad science division, except with better funding and a genuine fear that the Soviets might be better at the whole world domination through technology thing. Think about it. How do you get a computer in California to send a message to a computer in Massachusetts when they're made by different companies, run different software, and have never been designed to communicate with anything except their own keyboards and printers? It's like trying to get a French poet to collaborate on a haiku with a German engineer using only interpretive dance. The solution would require inventing entirely new concepts, packet switching, network protocols, distributed systems, and fault-tolerant design. These weren't just technical challenges, they were conceptual revolutions that would reshape how we think about information, communication, and connection itself. Meanwhile, the Cold War was providing the perfect motivation. Every day that America didn't have a bomb-proof communication system was another day that the Soviets might gain an advantage. The fear of nuclear annihilation was literally funding the technology that would eventually let you argue with strangers about pizza toppings on social media. The irony is delicious. A project designed to help the military survive nuclear war would eventually become the platform for sharing baby photos, streaming music, and ordering food delivery. The same network designed to coordinate missile defense would one day coordinate flash mobs, viral dances, and global movements for social change. But we're getting ahead of ourselves. In the late 1960s, the internet was still just a gleam in a few researchers' eyes. The first challenge was proving that computers could communicate over long distances at all. It sounds simple now, but remember, this was an era when wireless communication meant radio, mobile computing was a contradiction in terms, and social networking happened at cocktail parties. The stage was set for one of the most important experiments in human history. Scientists at UCLA, Stanford, UC Santa Barbara, and the University of Utah were about to attempt something that had never been done before, connecting their computers across hundreds of miles and seeing if they could actually exchange information. What happened next would change everything. But that's a story for our next chapter, where we'll witness the birth of ARPANET and humanity's first tentative steps into the connected world that would eventually consume our lives, our attention, and our ability to remember phone numbers. The Cold War had accidentally commissioned the future. Now it was time to build it, one connection at a time. Now you have to understand the communication nightmare that was keeping Pentagon officials awake at night. Imagine trying to coordinate a response to a nuclear attack using the telephone system of 1957. You'd pick up the phone, dial the operator, wait for her to connect you, hope the lines weren't busy, and pray that a single severed cable wouldn't cut off communication between Washington and, well, everywhere else that mattered. The existing telephone network was like a giant spider web, except if you cut one strand, entire sections would collapse into digital darkness. It was centralized, fragile, and about as reliable as a chocolate teapot in a nuclear winter. Military planners realized that in a real crisis, they might find themselves trying to coordinate the defense of the free world using smoke signals and carrier pigeons. This is where our first hero enters the story, JCR Licklider, a psychologist turned computer visionary who had ideas so far ahead of his time that his colleagues probably checked his coffee for hallucinogens. Licklider wasn't just thinking about better military communications, he was imagining something he called the Intergalactic Computer Network. Yes, really. The man was essentially describing the internet in 1962, when most computers were room-sized monsters that required their own air conditioning systems. Licklider understood something that seems obvious now, but was revolutionary. Then computers weren't just giant calculators. They were communication devices waiting to happen. He envisioned a world where computers could talk to each other, share information, and create a network so robust that it could survive almost any catastrophe. It was like imagining smartphones in the age of rotary phones, technically possible, but requiring a leap of imagination that most people simply couldn't make. But Licklider wasn't just a dreamer, he was a dreamer with a government budget. As the head of DARPA's Information Processing Techniques Office, he had the power to turn science fiction into science fact. He started funding research into computer networking, time-sharing systems, and interactive computing. He was essentially writing checks for the future, hoping that brilliant people would figure out how to cash them. The challenge was enormous. In the 1960s, computers were like isolated islands of intelligence. Each machine spoke its own language, used its own protocols, and had about as much interest in communicating with other computers as cats have in forming book clubs. Getting them to talk to each other would require solving problems that hadn't even been properly defined yet. October 29th, 1969. While most of America was obsessing over the moon landing from 4 months earlier and wondering if bell-bottom jeans were a good investment, a small group of researchers at UCLA was about to make history in a much quieter way. They were preparing to send the first message over what would eventually become the internet, and they had no idea they were about to accidentally invent the future of human communication. Picture the scene, a cramped computer lab filled with the gentle hum of room-sized machines, the smell of hot electronics, and the nervous energy of people who are either about to make history or spectacularly embarrass themselves in front of their funding agencies. The computer in question was an IMP, an interface message processor, which sounds impressive until you realize it had less processing power than a modern toaster and was about as user-friendly as a tax audit. The plan was beautifully simple and terrifyingly complex at the same time. UCLA would attempt to log into a computer at Stanford Research Institute, about 350 miles away. Today, this would be like getting excited about successfully turning on a light switch. But in 1969, it was like attempting to telepathically communicate with someone on Mars while juggling flaming torches. Our protagonist for this historic moment was Charlie Klein, a 21-year-old UCLA student who probably had no idea that his typing skills were about to become legendary. Charlie was tasked with the monumentally important job of typing login on his computer and seeing if it would somehow magically appear on a screen hundreds of miles away. Now let's pause for a moment to appreciate the sheer audacity of this experiment. Remember, this was 1969. The most advanced communication technology most people had access to was the telephone, and even that required an operator to connect long-distance calls. The idea that two computers could talk to each other across vast distances was so far-fetched that it belonged in science fiction novels, not university research labs. The technical challenges were staggering. How do you break a message into pieces, send those pieces across telephone lines that were never designed for computer data, and then reassemble them correctly on the other end? It's like trying to mail someone a jigsaw puzzle by sending one piece at a time through different postal services and hoping they all arrive in the right order. This is where packet switching comes in, one of those concepts that sounds boring but is actually more revolutionary than sliced bread. Instead of establishing a dedicated connection between two computers like a telephone call, packet switching breaks messages into small chunks, sends each chunk independently, and reassembles them at the destination. It's like having a conversation by writing each word on a separate piece of paper, throwing them all in the air, and trusting that the person on the other end can put them back together in the right order. The beauty of packet switching is its resilience. If one route is blocked, the packets can take a different path. If some packets get lost, the system can request replacements. It's a communication method designed by paranoid people for an unreliable world, which, as it turns out, perfectly describes both the Cold War era and the modern internet. But back to our historic moment. Charlie Klein sits down at his terminal, takes a deep breath, and begins typing. He types LA and calls his counterpart at Stanford. Did you get the L? Yes, they got the L. He types O and calls again. Did you get the O? Yes, they got the O. So far so good. This is going better than anyone dared hope. Then Charlie types G for the third letter of login, and the system crashes. Let that sink in for a moment. The first message ever sent over what would become the internet was LO, as in lo and behold. It's like the universe had a sense of humor about this whole thing. Here they were trying to send login, and instead they accidentally sent what might be the most appropriate greeting in the history of human communication. But here's the thing about researchers. They don't give up when something crashes. They debug, they troubleshoot, and they try again. Within an hour they had the system working, and the full login message went through successfully. It wasn't as poetic as LO, but it was complete, and it proved that the concept worked. What happened in that UCLA lab wasn't just a successful computer connection, it was the first crack in the wall between isolated machines and networked intelligence. For the first time in history, a computer in one location could directly communicate with a computer in another location, without human intervention. It was like watching two artificial brains shake hands across the void. The implications were staggering, even if nobody fully understood them yet. This wasn't just about military communications or academic research, though that's what everyone thought at the time. This was the first step toward a world where information could flow freely between any 2 points on the planet, where distance would become irrelevant, and where the collective knowledge of humanity could be accessible to anyone with a connection. But let's be honest, the immediate reaction was more neat trick than world-changing revolution. The researchers were excited, sure, but they were thinking about things like remote access to expensive computers and sharing research data. Nobody was imagining cat videos, social media, or the ability to order pizza by tapping a screen. The ARPANET, as this fledgling network was called, grew slowly at first. By the end of 1969, there were 4 nodes: UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. 4 computers, connected by telephone lines, capable of sending messages to each other. It was like the world's most exclusive club, except the membership requirement was having a room-sized computer and a government research grant. Each new connection was an adventure. Getting computers from different manufacturers to talk to each other was like trying to get speakers of different languages to have a conversation without a translator. Every machine had its own quirks, its own protocols, and its own ways of interpreting data. The researchers were essentially inventing a universal language for computers, a digital Esperanto that would eventually become the foundation of all internet communication. The early ARPANET was fragile, temperamental, and required constant attention. Messages would sometimes disappear into the digital ether. connections would drop without warning. The whole system would occasionally decide to take an unscheduled break, leaving researchers staring at blank screens and wondering if they had imagined the whole thing. But it worked, slowly, unreliably, and with frequent technical tantrums, but it worked. Researchers could log into remote computers, share files, and send messages. It was like having a very primitive, very expensive version of email and file sharing, available only to a handful of universities and research institutions. The beauty of that first LO message wasn't in its content, it was in its existence. It proved that the fundamental concept was sound. Computers could talk to each other across long distances. Information could be packaged, transmitted, and reassembled. The dream of a connected world had taken its first tentative step into reality. Of course, nobody knew they were witnessing the birth of the internet. They thought they were building a better way for researchers to share computer resources. They had no idea they were creating the infrastructure for a global revolution in human communication, commerce, and culture. The first internet message was LO, but it might as well have been Hello Future, because on that October day in 1969, the future had officially begun. If the birth of ARPANET in 1969 was like a baby's first word, then the early 1970s were like watching that same baby learn to walk. Lots of wobbling, frequent falls, and the occasional spectacular crash into the furniture. But just like proud parents, the researchers at DARPA and various universities watched their digital offspring take its first tentative steps across the country, connecting more computers and, more importantly, more minds. By 1971, ARPANET had grown from its original 4 nodes to a whopping 15. To put this in perspective, your neighborhood probably has more Wi-Fi networks than the entire internet had computers in 1971. But each new connection was a victory, a proof of concept, and a step towards something that nobody quite understood yet, but everyone sensed was important. The network was still primarily the playground of researchers, graduate students, and the occasional curious professor who had figured out how to log in without crashing the system. These early internet pioneers were like digital explorers, mapping out the possibilities of connected computing with the enthusiasm of kids in a candy store and the technical skills to actually make it work. But here's where things get interesting, and where we start to see the first hints of what the internet would eventually become. Because when you give smart, curious people a new way to communicate, they don't just use it for official business. They start experimenting, playing, and pushing boundaries in ways that would make their funding agencies either very proud or very nervous. The first email was sent in 1971 by Ray Tomlinson, a programmer who was essentially trying to figure out how to send messages between different computers on the network. Now, Tomlinson didn't set out to revolutionize human communication, he was just solving a practical problem. But in doing so, he accidentally invented something that would eventually make the postal service look quaint and give birth to the phrase "you've got mail." Tomlinson's stroke of genius was using the @ symbol to separate the user name from the computer name. It seems obvious now, but in 1971, it was like discovering fire. The @ symbol, which had been quietly sitting on typewriter keyboards for decades without much purpose, suddenly became the most important punctuation mark in the digital age. Every email address since then has been a tribute to Tomlinson's moment of inspiration. The first email message, Tomlinson himself admits he can't remember exactly what it said, describing it as something like QWERTY UIOP. Basically, he was just testing to see if the system worked. So the first email in history was essentially digital gibberish, which, let's be honest, perfectly foreshadows about 90% of all future internet communication. But email wasn't just a technical achievement, it was a social revolution waiting to happen. For the first time in human history, people could send written messages instantly across vast distances without involving the postal service, telegraph operators, or carrier pigeons. It was like having a personal messenger who could travel at the speed of light and never got tired or asked for a raise. The early ARPANET users quickly discovered that email was addictive. Researchers who had previously communicated through formal letters or expensive long-distance phone calls suddenly found themselves exchanging messages throughout the day. It was immediate, informal, and incredibly convenient. Plus, unlike phone calls, you could send an email at 3 a.m. without waking anyone up, a feature that graduate students and insomniacs immediately appreciated. By 1973, email traffic accounted for 75% of all ARPANET activity. Think about that for a moment. A network designed for sharing computer resources and conducting research was primarily being used for people to send messages to each other. It was like building a highway for trucks and discovering that most of the traffic was bicycles. The network was evolving in ways its creators never anticipated. This period also saw the development of some of the fundamental protocols that still power the Internet today. The Transmission Control Protocol (TCP) was being developed by Vint Cerf and Bob Kahn, two researchers who were essentially trying to solve the problem of how to get different networks to talk to each other. It's like they were inventing a universal translator for computers, except instead of dealing with Klingon and Vulcan, they were dealing with IBM and DEC. The challenge was enormous. Different computer networks used different protocols, different addressing schemes, and different ways of handling errors. Getting them to communicate was like trying to organize a United Nations meeting where every delegate speaks a different language and has different rules about when it's appropriate to interrupt. Cerf and Kahn's solution was elegant in its simplicity: create a common protocol that could sit on top of all the different network technologies, like a diplomatic interpreter who could translate between any two languages. TCP would break messages into packets, send them across whatever networks were available, and reassemble them at the destination. It was packet switching taken to its logical conclusion, a way to send data across a network of networks. But the early 1970s weren't just about technical achievements, they were also about discovering the social implications of connected computing. Researchers began forming online communities, sharing not just data but ideas, jokes, and the occasional flame war. The first mailing lists appeared, allowing groups of people to discuss topics of mutual interest without being in the same physical location. One of the most popular early mailing lists was SF Lovers, dedicated to discussing science fiction. Here were serious researchers and graduate students spending their time on a government-funded network debating the relative merits of Isaac Asimov versus Robert Heinlein. It was like using a Formula One race car to deliver pizza. Technically possible, but probably not what the designers had in mind. The network was also becoming more reliable, though reliable is a relative term. Messages usually got through, connections usually stayed up, and the system usually didn't crash more than once a day. For researchers accustomed to computers that required constant babysitting, this was practically miraculous. By 1975, ARPANET was no longer an experiment. It was a working network with dozens of nodes, hundreds of users, and thousands of messages flowing through it every day. It had proven that computer networking was not only possible but practical. More importantly, it had demonstrated that when you connect computers, you don't just connect machines, you connect the people who use them. The stage was set for the next phase of Internet evolution. The basic technology worked, the protocols were being refined, and a growing community of users was discovering new ways to use the network. What started as a military research project was becoming something much more interesting, a platform for human connection and collaboration that would eventually change everything. But we're still in the early days. The Internet of 1975 was like a small town where everyone knew everyone else. Messages were polite, And the biggest controversy was whether it was appropriate to use the network for non-research purposes. That innocent age was about to end, and the internet was about to discover what happens when you scale up from dozens of users to millions. Imagine trying to organize a global conversation where everyone speaks a different language, follows different rules, and has completely different ideas about basic things like what constitutes a sentence, or when is it polite to interrupt. Now imagine that instead of people, you're dealing with computers, and instead of languages, you're dealing with network protocols. Welcome to the late 1970s, when the internet was having an identity crisis that would make a teenager look emotionally stable. By 1975, ARPANET was no longer the only game in town. Computer networks were sprouting up everywhere like digital mushrooms after rain. There was CSNet for computer science departments, BATNet for academic institutions, UUCP for Unix systems, and a dozen other networks with names that sounded like they were invented by committees of engineers who had given up on marketing entirely. Each network had its own personality, its own rules, and its own way of doing things. It was like having separate internet neighborhoods, where the residents of each area spoke different languages and had different customs. You could send a message within your own network just fine, but trying to communicate with someone on a different network was like trying to order coffee in a foreign country using only interpretive dance. This is where our heroes enter the story. Vint Cerf and Bob Kahn, two researchers who looked at this chaos and thought, you know what this needs? A universal translator. Except instead of translating between human languages, they wanted to create a protocol that could translate between different computer networks. They called it the Internet Protocol, or IP, and it would eventually become the foundation of everything you do online. But first, let's talk about why this was such a big deal. In the mid-1970s, if you wanted to send a message from a computer on ARPANET to a computer on, say, a satellite network, you couldn't. It was like trying to mail a letter from the United States to Europe using only domestic postal services. The systems simply weren't designed to work together. Cerf and Kahn had a radical idea. What if instead of trying to get all the different networks to speak the same language, they created a common language that could sit on top of all the existing networks? It would be like having a universal translator that could work with any language, allowing people from different countries to communicate without everyone having to learn Esperanto. The technical challenges were staggering. Different networks had different maximum message sizes, different reliability guarantees, and different ways of handling errors. Some networks were fast but unreliable, like sending messages by carrier pigeon in a thunderstorm. Others were slow but dependable, like sending messages by tortoise with a GPS tracker. Their solution was brilliant in its simplicity. Break every message into small standardized packets. Give each packet enough information to find its own way to the destination, and let the receiving computer worry about putting them back together. It was like sending a jigsaw puzzle through the mail by putting each piece in a separate envelope with the same address. Chaotic in transit but perfectly organized when it arrives. The Transmission Control Protocol, TCP, handled the reliable delivery part, making sure that all the packets arrived and were reassembled in the correct order. The Internet Protocol, IP, handled the addressing and routing, making sure each packet knew where it was going and how to get there. Together, TCP/IP became the diplomatic language of the Internet, allowing any computer on any network to communicate with any other computer on any other network. But here's the thing about revolutionary ideas: they don't automatically win just because they're better. TCP/IP had to compete with other networking protocols, some of which were backed by major corporations with deep pockets and strong opinions about how computer networking should work. The biggest competitor was OSI, the Open Systems Interconnection Model, which was backed by international standards organizations and major computer companies. OSI was like the formal committee-designed approach to networking, with 7 carefully defined layers and enough documentation to fill a small library. TCP/IP, by comparison, was like the scrappy upstart that actually worked in the real world. The battle between TCP/IP and OSI was like watching a street-smart kid from the wrong side of the tracks compete against the valedictorian from the fancy prep school. OSI had better credentials, more official support, and a more theoretically elegant design. TCP/IP had something more important. It actually worked, and people were already using it. The turning point came in 1983, when ARPANET officially switched from its original Network Control Protocol, NCP, to TCP/IP. This wasn't just a technical upgrade, it was a declaration of independence. ARPANET was no longer just a single network. It was becoming the backbone of a network of networks, an internet with a lowercase I, that would eventually become the internet with a capital I. The transition wasn't smooth. January 1, 1983, was designated as Flag Day, the day when all ARPANET hosts had to switch to TCP/IP or be disconnected from the network. It was like changing the rules of the road while everyone was still driving. Some systems crashed, some messages got lost, and some researchers spent New Year's Day debugging network connections instead of nursing hangovers. But it worked. Suddenly, computers that had never been able to communicate before could exchange messages as easily as neighbors chatting over a fence. Universities could connect their local networks to ARPANET and instantly become part of a larger community. Research institutions could share resources and collaborate in ways that had never been possible before. The adoption of TCP/IP also solved another crucial problem: scalability. The original ARPANET protocols worked fine for a few dozen computers, but they would have collapsed under the weight of thousands or millions of connections. TCP/IP was designed from the ground up to handle massive scale, with addressing schemes that could theoretically support billions of devices. Of course, nobody in 1983 was thinking about billions of devices. The idea that every person might someday carry a computer more powerful than the room-sized machines of the 1970s was pure science fiction. The researchers were thinking about connecting universities and research institutions, not about a world where your refrigerator would have an IP address. But the foundation was laid. TCP/IP provided the common language that would allow the internet to grow from a small academic network to a global communication platform. It was like building a highway system that could handle not just the cars of today, but the flying cars of tomorrow, even though nobody was quite sure what those flying cars would look like. The protocol wars of the late 1970s and early 1980s might seem like ancient history now, but they determined the fundamental architecture of the modern internet. Every time you send an email, stream a video, or update your social media status, you're using protocols that were designed by Vint Cerf and Bob Kahn to solve the problem of getting different networks to talk to each other. The victory of TCP/IP wasn't just a technical triumph, it was a philosophical one. It proved that simple, practical solutions could beat complex, theoretically perfect ones. It showed that protocols designed by researchers who actually used them could outcompete protocols designed by committees who never had to make them work in the real world. By 1983, the internet had its universal language, its common protocol, and its basic architecture. The stage was set for explosive growth, but first the network had to learn how to handle something it had never dealt with before: ordinary people who weren't computer scientists and didn't care about the elegant beauty of packet switching. They just wanted the thing to work. Let's talk about the moment when the internet stopped being just a tool for sharing computer resources and started being a place where humans actually lived. It happened gradually, then suddenly, and it all began with a simple realization: when you give people a way to send messages instantly across vast distances, they don't just use it for work, they use it to be human. By the mid-1970s, Email had gone from Ray Tomlinson's experimental QWERTY UI op to something that was consuming most of ARPANET's bandwidth. Researchers who had been granted access to this expensive, government-funded network for serious academic purposes were spending their time writing messages to colleagues, friends, and complete strangers about everything from quantum physics to the best pizza places near MIT. The transformation was remarkable. These were serious academics, people with PhDs and government security clearances, and they were acting like teenagers who had just discovered the telephone. They were staying up late to check their messages, developing inside jokes with people they'd never met in person, and creating the first online communities based on shared interests rather than geographic proximity. One of the earliest and most popular mailing lists was SF Lovers, created in 1975 for discussing science fiction. Here were some of the world's leading computer scientists and researchers spending their time debating whether Isaac Asimov's Foundation series was better than Frank Herbert's Dune novels. It was like discovering that the Manhattan Project scientists had been using their top-secret communications network to argue about comic books. But SF Lovers was just the beginning. Soon there were mailing lists for wine enthusiasts' wine, recipe sharing, called simply Recipes, and even one called Human Nets that was dedicated to discussing the social implications of computer networking. The researchers weren't just building the internet, they were accidentally inventing online culture. The early email culture was remarkably polite and intellectual. Messages were carefully composed, properly spelled, and often quite formal. People signed their full names and institutional affiliations. Flame wars existed, but they were conducted with the dignity of academic debates, complete with citations and footnotes. It was like the internet's brief period of childhood innocence before it discovered caps lock and emoji. But even in this polite environment, the fundamental dynamics of online communication were emerging. People discovered that email made them braver, more willing to share personal thoughts and controversial opinions. The asynchronous nature of email, you could write a message at 3 a.m. and send it to someone who would read it at 9 a.m., created a new kind of intimacy. You could have deep, thoughtful conversations with people you'd never met, sharing ideas and feelings that you might never express in person. The @ Ray Tomlinson's inspired choice for separating usernames from computer names became the most important punctuation mark in the digital age. Every email address was a unique identifier, a digital postal address that could reach you anywhere in the connected world. It was like having a personal mailbox that followed you wherever you went, except the mail was delivered instantly and the postman never took holidays. Email also introduced the concept of digital identity. Your email address became part of who you were, a way for people to find and contact you that was independent of your physical location. Researchers began including their email addresses on business cards and academic papers. It was the first hint of a world where your online presence would become as important as your offline one. The technical infrastructure was evolving to support this growing email culture. Message headers became more sophisticated, allowing for features like carbon copies, or CC, and blind carbon copies, or BCC. The concept of email forwarding emerged, allowing messages to follow you as you moved between institutions. Mailing list software became more sophisticated, with features like automatic subscription management and message archiving. But perhaps the most important development was the emergence of email etiquette, the unwritten rules of how to behave in this new digital medium. People learned not to type in all caps, which was considered shouting, to keep messages concise, and to be careful about tone since sarcasm and humor didn't always translate well in text. These early netiquette rules would eventually evolve into the complex social norms that govern all online communication. The mailing lists also became laboratories for democracy and community building. Groups developed their own cultures, their own inside jokes, and their own ways of handling conflicts. Moderators emerged to keep discussions on topic and civil. The concept of lurking, Reading messages without participating became accepted as a way for newcomers to learn the culture before jumping in. One of the most significant developments was the creation of ARPANET's first online newsletter, called the ARPANET News. It was distributed via email and contained updates about network developments, new nodes coming online, and technical announcements. But it also included more personal content, profiles of researchers, reports from conferences, and even the occasional joke. It was like the internet's first blog, decades before anyone knew what a blog was. The email culture of the late 1970s and early 1980s also saw the emergence of the first online romances. Researchers who had been corresponding about technical topics began sharing personal details, developing friendships, and sometimes falling in love. There were marriages that began with email exchanges between people who lived thousands of miles apart. The internet was becoming not just a tool for sharing information, but a place where real human relationships could form and flourish. By 1985, email had become so central to academic and research life that many institutions were scrambling to get connected to the network. Universities that weren't part of ARPANET felt like they were being left out of important conversations. The fear of missing out, FOMO though the term wouldn't be coined for decades, was driving network expansion faster than any government mandate could. The success of email also highlighted one of the internet's most important characteristics. It was a platform, not just a tool. The researchers who built ARPANET thought they were creating a way to share expensive computer resources. Instead, they had created a medium for human expression and connection that would eventually transform every aspect of society. Email taught the early internet community several crucial lessons that would shape the future of online communication. First, that people would use any communication technology primarily to communicate with other people, regardless of its intended purpose. Second, that online communities could form around shared interests rather than geographic proximity. Third, that digital communication could be both more intimate and more public than face-to-face conversation. Most importantly, email proved that the internet wasn't just about computers talking to computers, it was about people talking to people, with computers as the invisible intermediaries. The @ symbol wasn't just a technical notation, it was the first piece of internet grammar, the beginning of a new language for human connection in the digital age. The email culture of the early internet was like a small town where everyone knew everyone else, conversations were civil, and the biggest excitement was a new person joining the community. That innocent age was about to end as the network grew beyond the academic world and discovered what happened when you gave ordinary people the power to communicate instantly with anyone, anywhere, about anything. Picture this, it's 1985, and you're a college student who has just discovered that your university has something called electronic mail. You can send messages to students at other schools instantly for free, without stamps or envelopes, or waiting 3 days for delivery. It's like discovering that your dorm room has a secret portal to every other college in the country. Welcome to the moment when higher education accidentally became the internet's primary distribution network. The 1980s were the decade when the internet stopped being the exclusive playground of government researchers and defense contractors and started becoming the secret weapon of universities everywhere. It was like watching an exclusive club gradually open its doors to anyone with a student ID and a willingness to learn cryptic computer commands. The transformation began with CSNet, the Computer Science Network, which launched in 1981 with the revolutionary idea that computer science departments at universities should be able to communicate with each other even if they weren't important enough to be on ARPANET. It was like creating a junior varsity internet for schools that couldn't make the varsity team. CSNet was funded by the National Science Foundation, which had looked at ARPANET and thought, this is pretty cool, but what if we made it available to more than just the military-industrial complex? It was a radical idea, using taxpayer money to build communication infrastructure for education rather than defense. The NSF was essentially betting that connecting universities would produce more innovation than connecting missile silos. The early CSNet connections were often hilariously primitive by today's standards. Many universities connected via dial-up telephone lines that operated at speeds that would make modern internet users weep with frustration. Sending a single email could take minutes, and downloading a file was something you started before going to lunch and hoped would be finished when you got back. But speed wasn't the point, connection was. For the first time, a computer science professor at a small state university could collaborate directly with researchers at MIT or Stanford. Graduate students could access research papers and datasets from institutions they could never afford to visit. The internet was democratizing access to knowledge in ways that would have been impossible through traditional academic channels. The real game changer came in 1986 with the launch of NSFNet, the National Science Foundation's answer to ARPANET. While ARPANET was still primarily focused on defense research, NSFNet was explicitly designed to support academic research and education. It was like the difference between a private country club and a public library, both valuable, but with very different ideas about who should have access. NSFNet started with a backbone speed of 56 kilobits per second, which sounds pathetic now, but was blazingly fast for 1986. More importantly, it was designed to connect not just individual computers, but entire university networks. Suddenly, every student and faculty member at a connected university had potential access to the internet, not just the computer science elite. The impact on university culture was immediate and profound. Students who had grown up writing letters home once a week were suddenly sending daily emails to friends at other schools. Professors were collaborating on research projects with colleagues they'd never met in person. Graduate students were accessing library catalogs and research databases from around the world without leaving their dorm rooms. But perhaps the most significant change was in how knowledge was shared. Before the internet, academic research was distributed through journals that could take months or years to publish new findings. With email and file transfer, researchers could share their latest discoveries instantly with colleagues around the world. It was like replacing the Pony Express with teleportation. The university internet of the 1980s also saw the emergence of the first online academic communities. Mailing lists sprang up around specific research topics, allowing scholars from different institutions to engage in ongoing discussions about their work. It was like having a permanent academic conference that never ended and never required travel funding. One of the most popular early academic mailing lists was BitNet's listserv system, which allowed anyone to create and manage discussion groups on virtually any topic. Soon there were lists for medieval historians, molecular biologists, and philosophers, as well as more informal groups for graduate students to commiserate about their advisors and share job market gossip. The social dynamics of these early academic online communities were fascinating. Hierarchies that existed in the physical world, based on institutional prestige, academic rank, or personal connections, were flattened in the digital realm. A graduate student at a small college could contribute to a discussion and be taken seriously by full professors at Ivy League institutions, as long as their ideas were good. This democratization of academic discourse wasn't always welcomed by the old guard. Some senior faculty members were uncomfortable with the informal, egalitarian nature of online discussions. They were used to academic conversations that followed strict protocols of deference and hierarchy, and the internet's tendency to treat all participants as equals was unsettling. But students loved it. For the first time in history, they had direct access to the global community of scholars in their field. They could ask questions, share ideas, and get feedback from experts around the world. It was like having the world's largest graduate seminar, available 24 hours a day. The university internet also became a breeding ground for the hacker culture that would eventually shape the broader internet. Computer science students with access to university networks began exploring the boundaries of what was possible, writing programs, sharing code, and pushing the limits of the technology. They weren't malicious hackers, they were curious students who had been given access to the most advanced communication network in human history and wanted to see what it could do. This period also saw the development of many of the internet services that we take for granted today. File Transfer Protocol, or FTP, allowed users to share files across the network. Telnet enabled remote login to computers anywhere on the internet. Usenet created a distributed discussion system that was like a cross between email and a bulletin board. These weren't commercial products, they were tools created by students and researchers to solve their own problems and shared freely with the community. The university internet of the 1980s was also remarkably international. NSFNet connected to academic networks in Europe, Asia, and other regions, creating a truly global community of scholars. For the first time, a student in Iowa could collaborate directly with a researcher in Tokyo, or exchange ideas with a colleague in London. The internet was making the world smaller, and the academic community larger. By 1990, virtually every major university in the United States was connected to the internet, and many smaller colleges were scrambling to get online. The internet had become as essential to higher education as libraries and laboratories. Students were choosing schools based partly on the quality of their network connections, and faculty were factoring internet access into their decisions about where to work. The university internet of the 1980s was like a preview of the connected world that was coming. It showed what happened when you gave intelligent, curious people access to instant global communication. They used it to learn, to teach, to collaborate, and to build communities around shared interests. They also used it to procrastinate, to gossip, and to waste time in creative new ways, proving that even in the most academic environments, people remained fundamentally human. Most importantly, the university internet created the first generation of true internet natives, students who had grown up with email, file sharing, and online communities as normal parts of their educational experience. These students would graduate and enter the workforce with expectations about communication and collaboration that would eventually force the entire world to get online. The universities had accidentally become the internet's training ground, teaching millions of students how to live and work in a connected world. They had no idea they were preparing their graduates to transform every industry, every institution, and every aspect of human society. But that transformation was coming, and it would be led by people who had learned to think digitally in college computer labs and dorm rooms across America. March 1989. While most of the world was watching the Berlin Wall crumble and wondering if the Cold War was really ending, a mild-mannered British physicist named Tim Berners-Lee was sitting in his office at CERN, the European Physics Research Centre, staring at a problem that was driving him absolutely crazy. He had information scattered across different computers, different systems, and different formats, and there was no easy way to connect it all together. It was like having a library where every book was written in a different language and stored in a different building. Tim's solution to this problem would accidentally create the most transformative communication medium in human history. But at the time, he just wanted to make it easier for physicists to share research papers. The internet already existed in 1989, of course. Email was thriving, file transfer was working, and universities around the world were connected through various networks. But using the internet required knowing cryptic commands, remembering complex addresses, and having a pretty good understanding of how computers worked. It was like having a car that could take you anywhere in the world, but only if you were a trained mechanic who could rebuild the engine every few miles. Berners-Lee had a different vision. He imagined a system where information could be linked together in a web of connections, where you could jump from one document to another with a simple click, and where the complexity of the underlying network would be invisible to the user. He called it the World Wide Web, and his colleagues at CERN thought it was a nice idea that would probably be useful for sharing physics papers. They had no idea he was inventing the future. The concept wasn't entirely new. Visionaries like Vannevar Bush had imagined something similar in the 1940s with his theoretical Memex machine, and computer scientists had been working on hypertext systems for decades. But Berners-Lee had something his predecessors lacked: a global network that could actually make it work, and the practical experience of a working scientist who understood what people actually needed. His first breakthrough was HTML, Hypertext Markup Language, a simple way to format documents and create links between them. HTML was deliberately designed to be easy to learn and use. You didn't need to be a programmer to create a web page, you just needed to understand a few basic tags. It was like the difference between needing to be a printing press operator to publish a book and being able to type on a typewriter. The second breakthrough was HTTP, Hypertext Transfer Protocol, a simple way for computers to request and deliver web pages. HTTP was designed to be stateless and lightweight, which meant it could work over the existing internet infrastructure without requiring major changes. It was like creating a new postal service that could use the existing road system. The third breakthrough was the URL, Uniform Resource Locator, a simple addressing system that could point to any document anywhere on the internet. URLs were designed to be human-readable and easy to remember. Instead of having to know that a document was stored on computer 192.168, 1.1 in directory /usr/local/docs/physics/papers, you could just remember http://cern.ch/physics/papers. It was like replacing GPS coordinates with street addresses. But the real genius of Berners-Lee's system was its simplicity and openness. He deliberately chose not to patent his inventions, instead releasing them freely to the world. He understood that for the web to succeed, it needed to be universal, available to everyone, controlled by no one, and built on open standards that anyone could implement. The first web browser, called World Wide Web, later renamed Nexus to avoid confusion, was created by Berners-Lee himself in 1990. It was both a browser and an editor, allowing users to not just view web pages but create them as well. This was crucial. Berners-Lee understood that the web would only succeed if it was easy for people to contribute content, not just consume it. The first website, info.cern.shay, went online on August 6, 1991. It was a simple page explaining what the World Wide Web was and how to use it. By today's standards, it was incredibly basic, just text and links, no images, no multimedia, no interactive features. But it was revolutionary because it proved that the concept worked. You could click on a link and instantly jump to a related document, even if that document was stored on a computer thousands of miles away. The early web was like a small town where everyone knew everyone else. There were only a few hundred websites, mostly created by researchers and academics, who were excited about this new way to share information. Each new site was an event, discussed and celebrated by the small community of early adopters who understood they were witnessing something historic. But the web's growth was explosive. By the end of 1991, there were about 10 websites. By the end of 1992, there were about 50. By the end of 1993, there were over 600. The numbers were doubling every few months, and each new website made the web more valuable for everyone else. It was like a digital gold rush, except instead of mining for precious metals, people were mining for information and connection. The key to the web's success was its network effect. Unlike previous information systems, where the value was in the content itself, the web's value increased exponentially with each new page and each new link. Every website that joined the web made every other website more valuable by providing more destinations to link to and more sources of incoming links. The early web also demonstrated the power of user-generated content, though that term wouldn't be coined for another decade. Unlike traditional media, where content was created by professionals and consumed by audiences, the web allowed anyone to be both a creator and a consumer. Every user was a potential publisher, and every computer was a potential printing press. This democratization of publishing was revolutionary. For the first time in history, an individual with access to a computer and an internet connection could potentially reach a global audience without needing permission from editors, publishers, or broadcasters. It was like giving everyone their own television station, radio show, and newspaper all at once. The web also introduced the concept of browsing, the ability to wander through information space without a specific destination in mind. Unlike traditional research, where you had to know what you were looking for before you started, the web allowed for serendipitous discovery. You could start reading about physics and end up learning about medieval history just by following interesting links. It was like having a conversation with the collective knowledge of humanity. By 1991, it was clear that Berners-Lee had created something special. The web was growing faster than anyone had anticipated, and its potential applications were becoming obvious to anyone who used it. This wasn't just a better way to share physics papers, it was a new medium for human communication and expression. But the web was still primarily text-based and limited to academic and research institutions. It would take another innovation, the graphical web browser, to bring the web to ordinary people and transform it from a useful tool for researchers into the foundation of the digital economy and culture. Tim Berners-Lee had solved his original problem of connecting scattered information at CERN. In the process, he had accidentally created the platform that would eventually connect all human knowledge and transform every aspect of modern life. Not bad for a day's work by a physicist who just wanted to make his job a little easier. The World Wide Web was born, and the world would never be the same. It is now early 1993. And you're trying to explain the World Wide Web to your non-technical friends. Well, you say you type in these cryptic commands, and then text appears on your screen, and there are these things called links that you can follow to other documents. Their eyes glaze over faster than a donut in a bakery window. The web existed, it was growing, and it was revolutionary, but it was about as user-friendly as a tax audit conducted in ancient Latin. Then along came Mark Andreessen, a 22-year-old undergraduate at the University of Illinois, who looked at the text-based web browsers of 1992 and thought, you know what this needs? Pictures. Lots and lots of pictures. It was like someone looking at silent movies and saying, this would be better with sound, except Mark was about to invent the equivalent of Technicolor, surround sound, and 3D all at once. Working at the National Center for Supercomputing Applications, or NCSA, Mark teamed up with Eric Benner, a programmer whose attention to detail was legendary even by the obsessive standards of computer science. Together, they set out to create a web browser that would make the World Wide Web accessible to ordinary human beings, people who didn't know the difference between HTTP and HTML and didn't want to learn. Their creation was called Mosaic, and it was about to turn the internet from a tool for academics into a medium for everyone. But first, let's appreciate just how radical their vision was. In 1992, the idea of displaying images in line with text on a web page was controversial. Many academics argued that pictures would clutter up their serious documents and waste precious bandwidth. It was like arguing that newspapers would be better without photographs. Technically possible, but missing the entire point of visual communication. Andreessen and Benner ignored the critics and focused on creating something that would be intuitive to use. Mosaic featured a graphical interface with buttons, menus, and revolutionary concept, the ability to display images directly on web pages without requiring separate applications. You could see a picture of something while reading about it, which seems obvious now, but was mind-blowing in 1993. The first version of Mosaic was released in February 1993, and it spread through the internet community like gossip in a small town. Within weeks, everyone was talking about this amazing new browser that made the web actually fun to use. It was like the difference between reading a restaurant menu and actually seeing the food. Suddenly the web wasn't just informative, it was engaging. But Mosaic's real innovation wasn't just technical, it was philosophical. Previous web browsers had been designed by and for computer experts who were comfortable with command-line interfaces and cryptic error messages. Mosaic was designed for normal people who wanted to point, click, and see interesting things happen. It was the first web browser that treated the internet as a mass medium rather than a specialized tool. The impact was immediate and dramatic. Before Mosaic, the web was growing steadily but slowly, adding a few dozen new sites each month. After Mosaic, the web exploded. New websites were appearing daily, then hourly. The number of web servers went from about 50 in early 1993 to over 500 by the end of the year. It was like watching a small stream suddenly become a raging river. More importantly, the type of content on the web began to change. The early web had been dominated by academic papers, technical documentation, and research data. After Mosaic, people started creating websites about their hobbies, their businesses, their cats, and their opinions about everything from politics to pizza toppings. The web was becoming a reflection of human diversity rather than just academic interests. Mosaic also introduced the concept of web surfing, the ability to wander aimlessly through cyberspace, following interesting links and discovering unexpected content. Before Mosaic, using the web was like going to a library with a specific research goal. After Mosaic, it was like wandering through a vast bazaar where every stall contained something potentially fascinating. The browser wars were about to begin, though nobody called them that yet. Mosaic's success attracted the attention of commercial software companies who realized that web browsers might be more than just academic curiosities. Microsoft, Netscape, and others began developing their own browsers, each trying to add features that would attract users and developers. But Mosaic had already won the most important battle, the battle for the soul of the web. By making the internet accessible to non-technical users, Mosaic ensured that the web would become a mass medium rather than remaining a specialized tool for researchers and computer enthusiasts. It was like the moment when television stopped being a curiosity for electronics hobbyists and became a fixture in every American living room. The success of Mosaic also highlighted one of the internet's most important characteristics, the power of network effects. Each new user who joined the web made it more valuable for everyone else, because they were potential creators of new content and new links. Each new website made the web more interesting for all users because it provided more destinations to explore and more information to discover. Mosaic's graphical interface also introduced the concept of the web page as a designed space, rather than just a text document. Web designers began thinking about layout, color, typography, and visual hierarchy. The web was becoming not just an information delivery system, but a new medium for artistic and creative expression. The browser also made the web more democratic. Before Mosaic, creating and viewing web content required significant technical knowledge. After Mosaic, anyone could browse the web with minimal training, and creating simple web pages became accessible to non-programmers. It was like the difference between needing to be a trained typesetter to create a document and being able to use a word processor. By the end of 1993, Mosaic had been downloaded over 1 million times, an enormous number for software distribution in the pre-broadband era. More importantly, it had fundamentally changed people's expectations about what the internet could be. The web was no longer just a tool for accessing information, it was becoming a place where people could express themselves, build communities, and create new forms of entertainment and commerce. Marc Andreessen would go on to co-found Netscape and become one of the most influential figures in internet history. But his greatest contribution was already complete. He had given the World Wide Web its first pretty face, and in doing so he had made the Internet irresistible to ordinary people. Mosaic proved that the Internet's future lay not in serving the needs of computer experts, but in empowering everyone to participate in the digital revolution. It was the moment when the Internet stopped being about computers and started being about people. The age of mass Internet adoption was about to begin, and it would change everything. For over 2 decades, the Internet had been the exclusive playground of academics, researchers, and government agencies. It was like a private club, where the membership requirements included a PhD, a government security clearance, or at least the ability to configure a Unix system without crying. Commercial activity was not just discouraged, it was explicitly forbidden by the acceptable use policies that governed most Internet connections. But by the early 1990s, the Internet was facing a crisis of success. The network that had been designed to connect a few dozen research institutions was now serving thousands of universities and millions of users. The academic and government funding that had built the Internet was no longer sufficient to support its explosive growth. Something had to change, and that something was about to transform the Internet from a research tool into the foundation of the global digital economy. The first crack in the dam came in 1991, when the National Science Foundation lifted its ban on commercial use of NSFNet. It was a quiet policy change that most people didn't notice at the time, but it was like removing the no swimming sign from Niagara Falls. Suddenly, businesses could legally use the Internet for commercial purposes, and entrepreneurs began to realize that this global communication network might be useful for something other than sharing research papers. The early commercial Internet was like the Wild West, a lawless frontier where anything seemed possible, and nobody was quite sure what the rules were. The first businesses to go online were mostly computer companies and Internet service providers, organizations that understood the technology and could see its potential. But even they were making it up as they went along, creating new business models and new ways of reaching customers. One of the first major commercial successes was The World, launched in 1989 as the first commercial Internet service provider. For $20 a month, ordinary people could get a dial-up connection to the Internet and access to email, file transfer, and other services. It was like selling tickets to the future, and people were surprisingly willing to pay for the privilege of joining this exclusive digital club. But the real game changer was the World Wide Web, which provided a user-friendly interface for the Internet and made it accessible to non-technical users. Suddenly, businesses could create websites to showcase their products and services, and customers could browse and shop from the comfort of their homes. It was like the invention of the shopping mall, except this mall was open 24 hours a day and could be accessed from anywhere in the world. The first commercial websites were charmingly primitive by today's standards. They were mostly digital brochures, static pages with basic information about companies and their products. There was no online shopping, no interactive features, and certainly no social media integration. But they represented a fundamental shift in how businesses thought about reaching customers and how customers thought about finding information. One of the earliest and most successful commercial websites was Pizza Hut's, launched in 1994. Yes, you read that correctly. Pizza Hut was one of the Internet's pioneering e-commerce sites. They offered online ordering in select markets, and while the technology was clunky and the coverage was limited, it proved that people would actually use the Internet to buy real products and services. It was like the first successful airplane flight. Brief, limited, but proof that the concept could work. The commercialization of the Internet also led to the development of new technologies and services that we now take for granted. Secure online transactions required the development of encryption technologies like SSL secure sockets layer. Online shopping required new payment systems and fraud protection. Customer service required new ways of handling inquiries and complaints. Each challenge spawned innovations that made the internet more useful and more trustworthy for commercial activities. The early commercial internet was also remarkably democratic. Unlike traditional media, where reaching a large audience required significant capital investment in printing presses, broadcast equipment, or distribution networks, the internet allowed small businesses to compete with large corporations on relatively equal terms. A well-designed website could make a small company look as professional and established as a Fortune 500 corporation. This democratization of commerce was revolutionary. For the first time in history, a small business in rural Iowa could potentially reach customers anywhere in the world without needing a sales force, distribution network, or advertising budget. It was like giving every entrepreneur their own global storefront, complete with 24-hour access and unlimited shelf space. The period from 1991 to 1995 also saw the emergence of the first internet advertising. Banner ads appeared on websites, email marketing began to develop, and businesses started to realize that the internet wasn't just a new sales channel, it was a new advertising medium with unprecedented targeting capabilities. Unlike traditional advertising, which was broadcast to mass audiences, internet advertising could be targeted to specific individuals based on their interests and behavior. But the commercialization of the internet wasn't without controversy. Many of the academics and researchers who had built the internet were horrified to see their creation being used for commercial purposes. They had envisioned the internet as a tool for advancing human knowledge and fostering collaboration, not for selling products and making profits. It was like watching your idealistic commune being turned into a shopping mall. The tension between the internet's academic origins and its commercial future led to heated debates about the proper role of business online. Some argued that commercial activity would corrupt the internet's culture of openness and collaboration. Others contended that commercial investment was necessary to fund the internet's continued growth and development. These debates would continue for years and still echo in discussions about internet governance and regulation today. Despite the controversies, the commercial internet grew explosively. By 1995, there were thousands of businesses online, millions of commercial websites, and billions of dollars in online transactions. The internet had evolved from a research network into a commercial platform that was beginning to transform entire industries. The success of early commercial internet ventures also attracted the attention of investors and venture capitalists, who began to see the internet as a new frontier for investment and growth. This influx of capital would fuel the next phase of internet development and lead to both spectacular successes and spectacular failures in the years to come. But perhaps the most important consequence of the internet's commercialization was cultural. By 1995, the internet was no longer seen as a tool for academics and computer enthusiasts. It was becoming a mainstream medium that ordinary people used for shopping, entertainment, and communication. The internet was transitioning from a specialized tool to a general-purpose platform that would eventually touch every aspect of human life. The commercialization of the internet between 1991 and 1995 was like watching a small town grow into a major city. The infrastructure expanded, new services appeared, and the population exploded. But unlike physical cities, this digital metropolis had no geographic boundaries and could grow infinitely in all directions. The Wild West phase of the commercial internet was ending, and the age of internet business was beginning. The stage was set for the dot-com boom, the development of e-commerce, and the transformation of the internet from a communication tool into the backbone of the global economy. The internet had learned to make money, and money would ensure that the internet would continue to grow and evolve at an unprecedented pace. By 1994, Mark Andreessen had graduated from the University of Illinois and moved to Silicon Valley, where he was working for a small company and probably wondering if his Mosaic browser had been just a lucky accident. Meanwhile, Jim Clark, the founder of Silicon Graphics, was looking for his next big venture and had become convinced that the internet was about to explode into mainstream consciousness. When these two met, it was like watching a match meet gasoline. The result was spectacular, transformative, and occasionally dangerous. Clark had the business experience and the connections. Andreessen had the technical vision and the credibility. Together, they founded Mosaic Communications Corporation in April 1994, with the ambitious goal of creating not just a better web browser, but an entire suite of internet software that would make the web accessible to everyone. It was like deciding to build not just a better car, but an entire transportation system. There was just one problem: they couldn't use the name Mosaic, because that belonged to the University of Illinois. So they renamed their company Netscape Communications, and their browser became Netscape Navigator. It was a minor setback that turned into a marketing goldmine. The name Navigator perfectly captured what their software was designed to do: help people navigate the vast, confusing, and rapidly expanding World Wide Web. Netscape Navigator wasn't just an improved version of Mosaic, it was a complete reimagining of what a web browser could be. Where Mosaic had been a proof of concept, Navigator was a polished product designed for mass market adoption. It was faster, more stable, and packed with features that made web browsing not just possible, but actually enjoyable. The browser introduced innovations that we now take for granted: progressive image loading, so you could see pictures appear gradually as they downloaded, support for background colors and images, and the ability to view web pages while they were still loading. These might seem like minor improvements, but in the dial-up era of 1994, they were the difference between a frustrating experience and a magical one. But Netscape's real innovation was understanding that the browser was just the beginning. They envisioned a world where the web would become the primary interface for all computer applications: email, file sharing, multimedia, and eventually commerce. It was like looking at the first automobiles and imagining not just better cars, but entire cities built around automotive transportation. The company's launch strategy was brilliant and unprecedented. Instead of following the traditional software model of selling through retail stores, Netscape made Navigator available for free download over the internet. Anyone could visit their website, download the browser, and start using it immediately. It was like giving away free samples, except the samples were full-featured products, and the distribution cost was essentially zero. This strategy worked spectacularly. Within months, Navigator had captured the majority of the browser market, and Netscape had become the most recognizable name on the internet. People weren't just using Navigator to browse the web, they were using it to discover what the web could be. Every new feature that Netscape added became a standard that other websites could build upon. The success of Navigator also demonstrated the power of network effects in the internet age. Each person who downloaded Navigator made the web more valuable for everyone else, because web developers could assume that users had access to Navigator's advanced features. Each website that used Navigator's capabilities made the browser more valuable to users, because it provided a richer, more engaging experience. Netscape also pioneered many of the business models that would define the internet economy. They gave away their browser for free to consumers, while charging businesses for server software and development tools. They created an ecosystem where free products drove demand for premium services. It was like giving away razors to sell razor blades, except the razors were software and the blades were enterprise solutions. The company's rapid growth attracted massive attention from investors, media, and competitors. By 1995, Netscape was being hailed as the poster child for the internet revolution, and Mark Andreessen was appearing on magazine covers as the face of the new digital economy. It was like watching a garage band suddenly become the biggest act in music, except instead of selling records, they were selling the future. But Netscape's success also attracted the attention of Microsoft, which had initially dismissed the internet as a passing fad. Bill Gates and his team realized that if the web became the primary interface for computing, it could threaten Microsoft's dominance of the desktop software market. The browser wars were about to begin, and they would be fought with the intensity of a religious conflict. Microsoft's response was swift and decisive. They began developing Internet Explorer, their own web browser, and announced plans to bundle it with Windows. It was like a chess grandmaster suddenly realizing that their opponent had been setting up a devastating attack and scrambling to mount a defense. The competition between Netscape and Microsoft would define the next phase of Internet development. Both companies began adding new features at a breakneck pace, often implementing proprietary extensions that worked only with their own browsers. Web developers found themselves caught in the middle, trying to create sites that worked well with both browsers while taking advantage of the latest innovations. This period of rapid innovation was both exhilarating and frustrating. New capabilities were being added to web browsers faster than standards organizations could document them. Websites became more sophisticated and interactive, but they also became more fragmented as developers chose sides in the browser wars. Netscape's influence extended far beyond just web browsing. The company helped establish many of the conventions that still govern internet business today: the importance of user experience, the power of network effects, the viability of software distribution over the internet, and the potential for small companies to rapidly scale to global significance. The browser also changed how people thought about software. Instead of applications that lived on individual computers, Netscape demonstrated the potential for web-based applications that could be accessed from anywhere. It was an early glimpse of what would eventually become cloud computing, software as a service, and the app-based economy. By the end of 1995, Netscape Navigator was being used by millions of people around the world, and the company was preparing for one of the most anticipated initial public offerings in business history. The internet was no longer just a tool for academics and early adopters, it was becoming a mass medium that ordinary people used for information, entertainment, and increasingly commerce. Netscape had succeeded in making the internet accessible to everyone, but in doing so, they had also made it attractive to everyone, including competitors with deeper pockets and broader distribution channels. The browser wars were just beginning, and the outcome would determine not just which company dominated web browsing, but which vision of the internet's future would prevail. The revolution that began with Mosaic and accelerated with Navigator was transforming the internet from a specialized tool into a general-purpose platform. The web was becoming the interface through which people accessed information, conducted business, and connected with each other. Netscape had lit the fuse on the internet explosion, and the blast was about to reshape the entire world. Again, it is 1993, and you're sitting in front of a computer that costs more than most people's cars. You've just heard about this thing called the World Wide Web, and you're dying to see what all the fuss is about. But here's the catch: you need something called a browser to actually see these magical web pages. It's like needing a special pair of glasses to see a parallel universe, except these glasses cost nothing and might just change everything. Enter Mark Andreessen, a 22-year-old computer science student at the University of Illinois, who was probably surviving on ramen noodles and caffeine. While his peers were cramming for finals, Mark was busy creating something that would make him richer than most lottery winners. He called it Mosaic, and it was about to turn the internet from a text-based academic playground into a visual wonderland. But let's back up for a second. Before Mosaic, browsing the web was like reading a novel written entirely in Times New Roman 12-point font, functional, but about as exciting as watching paint dry. Tim Berners-Lee's original World Wide Web browser was revolutionary for its time, but it had all the visual appeal of a tax document. Users had to type cryptic commands and navigate through endless menus just to view a simple web page. It was like trying to order coffee in a foreign language while blindfolded. Andreessen and his team at the National Center for Supercomputing Applications, or NCSA, had a different vision. They wanted to create a browser that could display images in line with text, a concept so radical that many academics scoffed at it. Why would anyone want pictures cluttering up their serious academic documents? They asked. Oh, how wrong they were. It's like asking why anyone would want color television when black and white works just fine. The development of Mosaic was a masterclass in collaborative chaos. Picture a dorm room filled with empty pizza boxes, overflowing ashtrays, and the constant glow of computer screens. Andreessen worked alongside Eric Beener, a programmer whose attention to detail bordered on obsessive. While Mark dreamed big, Eric made those dreams actually work. It was like having a visionary architect paired with the world's most meticulous construction foreman. Microsoft's response was swift and decisive. They launched Internet Explorer in 1995, bundled it with Windows, and declared war on Netscape. It wasn't just business competition, it was a battle for the soul of computing. Would the future belong to open web standards that anyone could implement, or would it be controlled by whoever owned the dominant operating system? The browser wars had officially begun, and they would be fought with the intensity of a religious conflict. Both companies began adding features at a breakneck pace, often implementing proprietary extensions that worked only with their own browsers. It was like two restaurants competing by adding more and more exotic ingredients to their menus, until customers needed a PhD in chemistry just to order lunch. Web developers found themselves caught in the crossfire. They had to choose build websites that worked best with Navigator and risk alienating Internet Explorer users, or create sites optimized for Internet Explorer and potentially lose the Netscape audience. Some tried to support both browsers, which meant essentially building two different websites and hoping they both worked. It was like being asked to write a book that could be read both forwards and backwards, while making sense in both directions. The competition drove rapid innovation, but it also created chaos. New HTML tags and JavaScript features were being introduced faster than standards organizations could document them. Websites became more sophisticated and interactive, but they also became more fragmented. The dream of a universal web where any browser could display any page was being shattered by the reality of corporate competition. Meanwhile, users were caught in the middle of this technological arms race. They had to choose sides, often without understanding the implications of their choice. It was like being forced to pick a team in a sport you'd never heard of, knowing that your choice would determine which half of the internet you could access properly. The browser wars also highlighted one of the internet's fundamental tensions, the conflict between innovation and standardization. Rapid innovation meant new features and capabilities, but it also meant incompatibility and fragmentation. Standardization meant universal access and compatibility, but it also meant slower development and compromise solutions that satisfied no one completely. By 1995, the battle lines were drawn. Netscape had the early lead and the support of web developers who appreciated open standards. Microsoft had the advantage of bundling Internet Explorer with Windows, giving them access to every PC user in the world. It was like a race between a sports car and a freight train. The sports car was faster and more agile, but the freight train had unstoppable momentum. The outcome of this battle would determine not just which browser dominated the market, but which vision of the Internet's future would prevail. Would the web remain an open platform where anyone could innovate, or would it become another Microsoft monopoly? The stakes couldn't have been higher, and the war was just getting started. The browser wars were about more than just software. They were about the future of human communication, commerce, and culture. Every click, every download, every website visit was a vote in an election that would determine how billions of people would access information for decades to come, and most of the voters didn't even know they were voting. The first version of Mosaic launched in February 1993 and spread through the internet community faster than gossip in a small town. Suddenly, the web wasn't just a collection of boring text documents, it was a multimedia experience. You could see pictures of galaxies, read about quantum physics while looking at actual particle collision images, and browse through digital art galleries. It was like the difference between reading about the Mona Lisa and actually seeing it. But Mosaic's success created an unexpected problem. It was too successful. The University of Illinois owned the rights to Mosaic, and they weren't particularly interested in turning it into a commercial venture. Meanwhile, Mark Andreessen had graduated and moved to Silicon Valley, where he met Jim Clark, a serial entrepreneur who looked at the exploding web and saw dollar signs dancing in his head. Clark and Andreessen founded Netscape Communications in 1994 with the goal of creating a commercial web browser that would make Mosaic look like a stone tablet. They couldn't use the Mosaic name due to legal issues, but they could use the experience and vision that had made Mosaic successful. It was like a rock band breaking up and the lead singer starting a new group, same talent, different name, bigger ambitions. Netscape Navigator launched in late 1994, and it was everything Mosaic had been, but better. Faster loading times, more features, better graphic support, and crucially, it was designed for ordinary people, not just computer scientists. Navigator made browsing the web feel less like operating a nuclear reactor, and more like flipping through a magazine. A really big magazine that contained everything humans had ever thought worth sharing. The success of Navigator was immediate and spectacular. Within months it had captured over 70% of the browser market. People weren't just using Navigator, they were evangelizing it. It was like the early days of the iPhone, when people would corner strangers at parties to show them what their new device could do. Except instead of a phone, it was a window into the entire world's knowledge. But success in the tech world is like blood in shark-infested waters. It attracts predators. And the biggest predator in the software ocean was Microsoft, a company that had built its empire by recognizing threats early and crushing them thoroughly. Bill Gates looked at Netscape's success and realized that if the web became the primary interface for computing, it could make Windows irrelevant. It was like watching someone build a bridge that might bypass your toll road. You either join them or destroy the bridge. August 9th, 1995. While most Americans were worried about whether they could program their VCRs to stop blinking 12 o'clock, a small internet company called Netscape was about to prove that the future wasn't just digital, it was profitable. Spectacularly, ridiculously, almost impossibly profitable. Their initial public offering would open at $28 per share and close the first day at $58, making 24-year-old Mark Andreessen worth $58 million before lunch. It was like watching someone win the lottery by inventing a new kind of lottery ticket. The Netscape IPO wasn't just a successful stock offering, it was the starting gun for the greatest speculative bubble in human history. Suddenly, everyone with a computer science degree and a business plan was the next potential billionaire. The internet wasn't just changing how people communicated, it was rewriting the rules of capitalism itself. But let's step back and understand what was really happening here. For most of the 1990s, the internet had been this fascinating curiosity that tech-savvy people talked about at dinner parties. Oh yes, I can send electronic mail to my colleague in Tokyo, they'd say, while everyone else nodded politely and wondered why anyone would want to type a letter on a computer when they could just pick up the phone. Then came the World Wide Web, and suddenly the internet wasn't just for academics anymore. It was for everyone. Your grandmother could look at pictures of her grandchildren. Your teenager could research school projects without going to the library. Your spouse could shop for Christmas presents without fighting for parking at the mall. The internet had evolved from a specialized tool into a mass medium, and mass media meant mass money. The venture capitalists of Silicon Valley, who had spent the early 1990s funding biotechnology companies and hoping for the next miracle drug, suddenly realized they had been looking in the wrong direction. The real gold rush wasn't in test tubes and laboratories, it was in servers and software. Every day, millions of new people were getting online, and each new user represented potential customers, potential revenue, and potential profits that could make the California gold rush look like a neighborhood lemonade stand. The math was intoxicating. Traditional businesses were limited by geography, physical infrastructure, and the laws of physics. Internet businesses could theoretically reach anyone anywhere, at any time, with virtually no marginal cost for each additional customer. It was like discovering a printing press that could produce money instead of newspapers, and the only limit was how fast you could feed it paper. Entrepreneurs began flooding Silicon Valley with business plans that all followed the same basic template. It's like existing business, but on the internet. There was Amazon, a bookstore, but on the internet. eBay, a flea market, but on the internet. And hundreds of other companies that promised to revolutionize everything from pet food delivery to grocery shopping to dating. The beauty of these internet business models was their scalability. A traditional bookstore could serve maybe a few thousand customers in its local area. Amazon could theoretically serve every literate person on the planet. A traditional auction house could hold maybe one auction per week for a few hundred bidders. eBay could host millions of simultaneous auctions for millions of bidders. The internet wasn't just making existing businesses more efficient, it was making entirely new business models possible. But here's where things got interesting, and by interesting, I mean completely insane. Investors began valuing internet companies not based on their current profits, or even their potential profits, but on their eyeballs, the number of people who visited their websites. It was like valuing a restaurant based on how many people walked past it on the sidewalk, regardless of whether they ever came inside or ordered anything. The logic, such as it was, went something like this. First, you build a website that attracts millions of users by giving away something valuable for free. Then once you have their attention, you figure out how to make money from them. It was like opening a nightclub, letting everyone in for free, serving free drinks all night, and assuming you'd figure out how to pay the bills later. The technical term for this business model was building mindshare, but it might as well have been called hoping for a miracle. The poster child for this new economy was a company called Yahoo, which started as a directory of interesting websites created by two Stanford graduate students who were procrastinating on their dissertations. Yahoo didn't sell anything, didn't manufacture anything, and didn't really do anything except organize links to other websites. But by 1996, it was worth more than many Fortune 500 companies that actually made physical products and employed thousands of people. The disconnect between internet valuations and traditional business metrics became so extreme that new vocabulary had to be invented to describe it. Companies that had never made a profit were valued in the billions based on their potential. Entrepreneurs who had never run a business were being hailed as visionaries. 20-something programmers were buying Ferraris with stock options from companies that existed only as websites and business plans. The media coverage of this phenomenon was breathless and largely uncritical. Business magazines featured cover stories about the new economy and the death of distance. Television shows profiled internet entrepreneurs as if they were rock stars or professional athletes. The message was clear. The old rules of business no longer applied, and anyone who didn't understand this was hopelessly behind the times. Traditional businesses watched this spectacle with a mixture of confusion and envy. Companies that had spent decades building factories, distribution networks, and customer relationships were suddenly worth less than websites that had been created in dorm rooms 6 months earlier. It was like watching someone win a marathon, by taking a helicopter to the finish line. Technically impressive, but somehow missing the point of the race. The psychological effect of the dot-com boom was profound. Suddenly, everyone knew someone who had become a millionaire by joining the right startup at the right time. Cocktail party conversations revolved around stock options, IPO dates, and which companies were pre-revenue versus post-revenue, as if having revenue was just one of many possible business strategies, like choosing between chocolate and vanilla ice cream. College students began dropping out to start internet companies, reasoning that a computer science degree was less valuable than 6 months of real-world experience in the fast-moving world of web development. MBA programs scrambled to add internet business courses to their curricula. Even established professionals began leaving secure jobs to join startups, lured by the promise of stock options that could make them rich if the company went public. The venture capital industry, which had traditionally been a conservative business focused on funding proven entrepreneurs with solid business plans, transformed overnight into something resembling a casino. VCs began funding companies based on PowerPoint presentations and the charisma of their founders. Due diligence became less about analyzing business fundamentals and more about getting in early on the next big thing before competitors did. By 1997, the internet economy had created its own ecosystem, complete with specialized lawyers, accountants, recruiters, and consultants who understood the unique challenges of building businesses in cyberspace. Silicon Valley real estate prices soared as thousands of entrepreneurs and engineers flooded the area. Restaurants began accepting stock options as payment. It was like an entire parallel economy had sprung up overnight, operating by different rules and different assumptions about what constituted value. But underneath all the excitement and speculation, something genuinely revolutionary was happening. The internet was creating new ways for people to connect, communicate, and conduct business. E-commerce was making it possible to buy anything from anywhere at any time. Search engines were making the world's information instantly accessible. Online communities were forming around shared interests rather than geographic proximity. The dot-com boom was built on a foundation of genuine innovation and real technological progress. The problem was that the financial speculation was running so far ahead of the actual technology that it was becoming impossible to distinguish between companies that were building the future and companies that were just riding the wave of investor enthusiasm. The gold rush mentality of the mid-1990s internet boom created both tremendous opportunities and tremendous risks. For every Amazon that would go on to dominate e-commerce, there were dozens of companies that would disappear without a trace when the bubble eventually burst. But in 1997, the bubble was still inflating, and everyone was convinced they were living through the greatest economic transformation in human history. They were right about the transformation part. They just didn't realize that the most spectacular booms are often followed by the most spectacular busts. Imagine walking into the world's largest library, except there's no card catalog, no librarian, no organization system whatsoever, and someone is adding 10,000 new books every hour while randomly moving the existing ones to different shelves. Oh, and about half the books are actually just advertisements disguised as books, and the other half might be completely wrong about everything they claim to contain. Welcome to the World Wide Web circa 1995, where finding information had become paradoxically harder than it had ever been in human history. This is the story of how we went from having too little information to having too much, and how a few clever programmers saved us all from drowning in the digital deluge they had helped create. In the early days of the web, and by early days I mean the ancient era of 1991 to 1993, finding websites was actually pretty easy. There were maybe a few hundred sites total, and most of them were listed on a single page maintained by Tim Berners-Lee at CERN. It was like having a phone book for a small town where everyone knew everyone else. Cozy, manageable, and completely unsustainable. By 1994, the web had grown to thousands of sites, and by 1995, there were hundreds of thousands. The single master list had become as useful as a phone book for the entire planet written in random order. People were creating websites faster than anyone could catalog them, and the web was transforming from a small organized community into a vast chaotic wilderness of information. The first attempts to solve this problem were charmingly primitive. Yahoo, founded by Jerry Yang and David Fillo in 1994, started as a simple directory where humans manually categorized websites into hierarchical lists. It was like having an army of librarians working around the clock to organize the world's fastest growing library, except the librarians were mostly college students, and the library was expanding faster than the speed of light. Yahoo! Its approach worked for a while, but it had obvious limitations. Human editors could only review and categorize so many websites per day, and the web was growing exponentially. It was like trying to count raindrops during a hurricane, theoretically possible, but practically hopeless. Plus, the human editors had their own biases and limitations. What seemed important to a computer science student at Stanford might be completely irrelevant to a small business owner in Ohio. The real breakthrough came from an unexpected source, academic computer science, where researchers were working on something called information retrieval. These were the same people who had been trying to figure out how to search through large databases of scientific papers, except now they were dealing with a database that contained everything from serious academic research to someone's vacation photos to advertisements for questionable products. The first automated search engines were crude but revolutionary. Programs like Archie in 1990 and Veronica 1992 could search through file names and basic text, but they were designed for the pre-web internet where most information was stored in organized file systems. When the web arrived with its chaotic mix of HTML pages, images, and multimedia content, these early search tools were about as useful as a paper map for navigating a constantly changing maze. Enter Web Crawler, launched in 1994 by Brian Pinkerton at the University of Washington. Web Crawler was the first search engine that could actually read and index the full text of web pages, not just their titles or file names. It was like the difference between judging books by their covers and actually reading them. Suddenly you could search for any word or phrase that appeared anywhere on any web page, and the search engine would find it for you. The concept was brilliant in its simplicity. Send out automated programs called spiders or crawlers to visit every web page they could find, read all the text on those pages, and create a massive index of every word on every page. When someone searched for a term, the engine would consult its index and return a list of pages that contained that term. It was like having a concordance for the entire internet, updated continuously by tireless robot librarians. But web crawler's success created a new problem: too many results. Search for pizza, and you might get 50,000 results. Which ones were actually useful? Which pizza places were near you? Which pages were selling pizza? Which were reviewing pizza? And which were just using the word pizza in passing? The early search engines were like having a librarian who could find every book that mentioned your topic, but couldn't tell you which ones were worth reading. This led to the next phase of search engine evolution: relevance ranking. Alta Vista, launched by Digital Equipment Corporation in 1995, was the first search engine to seriously tackle the problem of determining which results were most relevant to a user's query. Alta Vista used sophisticated algorithms to analyze not just whether a page contained your search terms, but how prominently those terms appeared, how often they were repeated, and how they related to other words on the page. Alta Vista was a revelation. It could search through millions of web pages in seconds and return results that were actually useful. It supported advanced search features like Boolean operators and Oregon, not and phrase searching. For the first time, ordinary people could find specific information on the web without knowing exactly where to look for it. It was like having a reference librarian with perfect memory and infinite patience. But even Alta Vista had limitations. The web was growing so fast that no single search engine could keep up with indexing all of it. Different search engines would return completely different results for the same query, leading to the frustrating experience of searching multiple engines to make sure you hadn't missed anything important. It was like having multiple incomplete maps of the same territory, useful, but requiring a lot of cross-referencing. The search engine wars of the mid-1990s were fierce and often bizarre. Companies competed not just on the quality of their results, but on the size of their indexes. We index 50 million pages. One would claim, well, we index 100 million. Another would respond, it was like competing over who had the biggest dictionary, regardless of whether anyone could actually find the words they were looking for. Meanwhile, the web itself was evolving in ways that made searching even more challenging. The rise of dynamic content meant that web pages were no longer static documents, but could change based on who was viewing them and when. E-commerce sites began creating millions of pages for individual products. The line between legitimate content and spam became increasingly blurred as website owners learned to game the search engines by stuffing their pages with popular keywords. The information overload problem was becoming acute. Studies showed that people were spending more time searching for information than actually using it. The web had solved the problem of information scarcity only to create the problem of information abundance. It was like replacing a desert with a flood, technically an improvement, but not necessarily easier to navigate. By 1998, there were dozens of search engines, each with its own strengths and weaknesses. Excite was good for natural language queries. Lycos had a comprehensive directory. Hotbot had advanced search features. Infoseek was fast and reliable, but none of them had solved the fundamental problem. How do you find exactly what you're looking for in a collection of information that's larger than any human can comprehend, and growing faster than any system can organize? The stage was set for a revolution in search technology. Somewhere in a Stanford University dorm room, two graduate students named Larry Page and Sergey Brin were working on a research project that would eventually become Google. They had a radical idea. Instead of just analyzing the content of web pages, what if you analyzed the links between them? What if the web's own structure could tell you which pages were most important and most relevant? But that's a story for our next chapter. For now, the web was drowning in its own success, and millions of users were learning to navigate the vast ocean of information with tools that were powerful but imperfect. The age of information overload had begun, and it would take a new kind of search engine to help humanity find its way through the digital wilderness we had created. The search engines of the 1990s had solved the problem of finding information on the web, but they had also revealed a deeper challenge in a world where anyone can publish anything. How do you separate the signal from the noise? How do you find not just information but good information? These questions would define the next phase of the Internet's evolution, and ultimately determine whether the web would become humanity's greatest library or its greatest distraction. July 16th, 1995. While most Americans were debating whether the O.J. Simpson trial would ever end and wondering if they should invest in this new thing called a CD-ROM, a former Wall Street hedge fund analyst named Jeff Bezos was sitting in his garage in Bellevue, Washington, packing books into boxes and trying to figure out how to ship them to customers he'd never met. His company, Amazon.com, had just sold its first book, Fluid Concepts and Creative Analogies by Douglas Hofstadter, and Bezos was about to discover that running an online bookstore was like trying to manage a library, a warehouse, and a shipping company all at the same time, except everything was on fire and moving at the speed of light. This is the story of how buying stuff online went from a crazy idea that only computer nerds would try to a trillion-dollar industry that would eventually make it possible to order toilet paper at 3 a.m. and have it delivered by drone. But first, let's talk about why anyone thought this was a good idea in the first place. In 1995, shopping was still a fundamentally physical activity. You got in your car, drove to a store, wandered around looking for what you wanted, stood in line to pay for it, and drove home. If the store didn't have what you wanted, you drove to another store. If no local stores had it, you either did without or ordered it from a catalogue and waited weeks for delivery. Shopping was time-consuming, frustrating, and limited by geography and store hours. It was like being trapped in a retail prison where the guards were surly teenagers and the visiting hours were 9 to 5. The early pioneers of e-commerce looked at this system and thought, there has to be a better way. What if you could browse through unlimited inventory from the comfort of your home? What if stores were open 24 hours a day, 7 days a week? What if you could compare prices instantly across multiple retailers? What if you never had to deal with pushy salespeople or crowded parking lots again? The technology was finally ready to make this vision possible. The World Wide Web provided a user-friendly interface for browsing catalogs. Secure Socket Layer, SSL, encryption made it safe to transmit credit card information over the internet. Database technology could handle large inventories and complex transactions. And most importantly, enough people were getting online to create a viable customer base. But there was one small problem. Nobody trusted the internet with their money. The early days of e-commerce were like trying to convince people to mail cash to strangers based on pictures in a magazine. The internet was still seen as a wild frontier populated by hackers, scammers, and people who spent too much time in their basements. The idea of typing your credit card number into a computer and sending it across the internet to buy something from a company you'd never heard of seemed about as safe as juggling chainsaws while riding a unicycle. Amazon's genius was starting with books. Books were perfect for e-commerce. They were standardized products that didn't need to be touched or tried on before purchase. They were relatively inexpensive, so the risk of a bad transaction was low. And most importantly, books were something that intelligent, educated people, the early internet adopters, actually wanted to buy. It was like choosing the perfect training wheels for the e-commerce bicycle. Bezos also understood something that many traditional retailers missed. The internet wasn't just a new sales channel, it was a completely different way of doing business. Physical bookstores were limited by shelf space. They could only stock a few thousand titles. Amazon could offer millions of books because they didn't need to keep them all in stock. They could order books from publishers and distributors only after customers ordered them. It was like having an infinite store with zero inventory costs. The early Amazon website was charmingly primitive by today's standards. The design looked like it had been created by someone who had learned HTML from a library book, which it probably had been. There were no fancy graphics, no multimedia presentations, no social media integration, just a simple search box, basic product descriptions, and a shopping cart that worked most of the time. It was like the Model T of e-commerce, not pretty, but it got you where you wanted to go. But Amazon's real innovation wasn't technological, it was cultural. They understood that online shopping needed to feel safe, reliable, and customer-friendly. They offered detailed product descriptions, customer reviews, and personalized recommendations. They made returns easy and customer service responsive. They treated every transaction as the beginning of a long-term relationship, rather than a one-time sale. It was like having a neighborhood bookstore owner who happened to have access to every book ever published and could deliver them to your door. The success of Amazon inspired a wave of imitators and innovators. If books could be sold online, why not everything else? CD Now started selling music CDs. Dell began selling computers directly to consumers. eBay created a platform for person-to-person auctions. Suddenly, entrepreneurs were racing to put every conceivable product and service online. The venture capital community went crazy for e-commerce startups. Any business plan that included the phrase "it's like existing retailer, but on the internet" could attract millions in funding. There was Pets.com for pet supplies, Webvan, groceries, eToys, for toys, and hundreds of others. The logic was simple: if Amazon could disrupt bookstores, then every retail category was vulnerable to internet disruption. The e-commerce boom created entirely new business models and ways of thinking about retail. The concept of the long tail emerged, the idea that online retailers could profitably sell small quantities of many different products, rather than large quantities of a few popular products. Personalization became possible on a massive scale, with websites tracking customer behavior and making individualized recommendations. Dynamic pricing allowed retailers to adjust prices in real time based on demand, competition, and inventory levels. But perhaps the most revolutionary aspect of e-commerce was how it changed customer expectations. Online shoppers could compare prices across multiple retailers instantly. They could read reviews from other customers before making purchases. They could shop at any time of day or night. They expected fast, free shipping and easy returns. Traditional retailers suddenly found themselves competing not just with other local stores, but with every retailer in the world. The psychological impact of e-commerce was profound. Shopping transformed from a social activity, something you did with friends or family, into a solitary digital experience. The instant gratification of clicking buy now created new forms of impulse purchasing. The ability to shop from home in your pajamas made retail therapy more accessible than ever before. Online shopping became a form of entertainment, with people browsing websites for fun even when they didn't need to buy anything. The infrastructure required to support e-commerce was staggering. Warehouses had to be redesigned for individual order fulfillment, rather than bulk shipments to stores. Shipping companies had to handle millions of small packages instead of thousands of large ones. Payment processing systems had to handle secure transactions 24/7. Customer service had to be available around the clock. It was like rebuilding the entire retail supply chain from scratch, except faster and more efficiently than the old system. By 1999, e-commerce had grown from Jeff Bezos packing books in his garage to a multi-billion-dollar industry that was reshaping the global economy. Online sales were doubling every year. Traditional retailers were scrambling to create their own e-commerce sites. The stock market was valuing internet retailers at astronomical multiples of their sales, betting that e-commerce would eventually dominate all retail. The dot-com boom was reaching its peak, and e-commerce companies were the darlings of Wall Street. Amazon's stock price had increased by over 2,000% since its eBay was facilitating billions of dollars in transactions between strangers. Even companies that had never made a profit were valued in the billions based on their potential to capture market share in the new digital economy. But underneath all the hype and speculation, something genuinely transformative was happening. E-commerce was democratizing retail, allowing small businesses to reach global markets and consumers to access products and services that had never been available to them before. It was creating new efficiencies in the supply chain and new conveniences for consumers. Most importantly, it was proving that the internet could be more than just a communication medium. It could be a platform for conducting real business with real economic value. The e-commerce revolution of the late 1990s laid the foundation for the digital economy we live in today. It established the principles of online retail, created the infrastructure for digital commerce, and changed consumer behavior in ways that would persist long after the dot-com bubble burst. Shopping would never be the same, and neither would the economy that depended on it. The garage where Jeff Bezos packed those first Amazon orders had become the birthplace of a retail revolution that would eventually touch every aspect of human commerce, and we were just getting started. Long before Facebook made it normal to share your breakfast photos with 500 friends, you barely know long before Twitter turned every random thought into a potential global controversy, and long before Instagram convinced us that everyone else's life was more photogenic than ours. There was a different kind of online community. These were places where people gathered not because an algorithm told them to, but because they genuinely shared interests, passions, and curiosities that couldn't be satisfied in their physical neighborhoods. This is the story of how the internet accidentally became the world's largest social experiment, and how millions of people discovered that you could form meaningful relationships with people you'd never met, might never meet, and sometimes didn't even want to meet in person. The roots of online community stretch back to the early 1980s, to something called bulletin board systems, or BBS. Picture this: you're a computer enthusiast in 1983, and you've just spent your life savings on a computer that has less processing power than a modern calculator. You're excited about your new hobby, but none of your friends or family understand why anyone would want to stare at a green screen and type cryptic commands. You feel like the only person in your town who thinks computers are cool. Then you discover that you can use your computer's modem to dial into a BBS, essentially a computer in someone's basement that other computer enthusiasts can call and leave messages for each other. Suddenly you're not alone anymore. There are dozens, maybe hundreds of people who share your passion for technology, programming, and the endless possibilities of personal computing. It's like finding your tribe, except your tribe is scattered across the country, and you communicate by typing messages on a computer screen. BBS were the internet's awkward adolescents, primitive, limited, but full of potential. Most could only handle one caller at a time, so you had to wait your turn to connect. Messages were organized into topic-based forums, and conversations could take days or weeks to develop as people took turns dialing in to read and respond to posts. It was like having a very slow, very patient conversation with a group of people who shared your interests but lived in different time zones. But even in this primitive form, online communities demonstrated something profound. People would go to extraordinary lengths to connect with others who shared their interests and passions. BBS users would spend hours crafting thoughtful messages, sharing knowledge, and building relationships with people they knew only as screen names and text on a computer screen. They were proving that human connection didn't require physical presence, it just required shared interests and the willingness to communicate. The real explosion in online communities came with the rise of commercial online services like CompuServe, America Online, known as AOL, and Prodigy in the late 1980s and early 1990s. These services were like training wheels for the internet, simplified, user-friendly environments where ordinary people could experience online communication without needing a computer science degree. AOL in particular became the gateway drug for millions of Americans' first online experiences. The company famously mailed out millions of free trial CDs, turning AOL into the most widely distributed software in history. But AOL's real innovation wasn't the CDs, it was creating online spaces that felt welcoming to non-technical users. AOL's chat rooms became the first mass-market online communities. They were organized by interest, such as sports, music, and hobbies, and by demographics, such as teens, seniors, and regional groups. For the first time, millions of ordinary people could log on and instantly find others who shared their interests or life circumstances. It was like having access to every club, support group, and social organization in the world, all from your home computer. The social dynamics of these early online communities were fascinating and sometimes disturbing. People discovered that they could be more honest, more open, and more themselves online than they ever were in person. The anonymity of screen names and the asynchronous nature of online communication created a kind of psychological safety that allowed people to share thoughts and feelings they might never express face to face. But this same anonymity also enabled behavior that would never be tolerated in physical communities. Trolling, deliberately posting inflammatory or offensive content to provoke reactions, became a common phenomenon. Online arguments, or flame wars, could escalate quickly and viciously, with participants saying things to each other that they would never say in person. The internet was teaching humanity that anonymity could bring out both the best and worst in people. The rise of Usenet in the early 1990s created a different model for online community. Unlike the centralized chat rooms of commercial services, Usenet was a distributed system of discussion groups, called newsgroups, that covered virtually every topic imaginable. There were groups for serious academic discussions, technical support, hobby enthusiasts, and, well, let's just say that Usenet proved that if you could imagine a topic, no matter how obscure or inappropriate, someone on the internet was interested in discussing it. Usenet introduced the concept of netiquette, the informal rules and social norms that governed online behavior. These weren't enforced by any central authority, but by the community itself through social pressure and peer moderation. People learned not to type in all caps, which was considered shouting, to stay on topic, and to be respectful of others' opinions. It was like watching a new form of civilization emerge, complete with its own customs, traditions, and social hierarchies. The early online communities also gave birth to internet culture as we know it today. Memes, ideas, jokes, or cultural references that spread rapidly through online communities became a new form of shared cultural experience. ASCII art, pictures made from text characters, became a primitive form of digital creativity. Emoticons evolved as a way to convey tone and emotion in text-based communication. The internet was developing its own language, humor, and forms of expression. One of the most significant developments was the emergence of online support communities. People dealing with rare diseases, unusual life circumstances, or stigmatized conditions could find others who understood their experiences in ways that their physical communities never could. Support groups for everything from addiction recovery to parenting challenges to professional development created new forms of mutual aid and emotional support that transcended geographic boundaries. The gaming communities that emerged in the 1990s created some of the most intense and lasting online relationships. Multi-user dungeons and early online games required players to cooperate, communicate, and build trust with teammates they might never meet in person. These gaming communities developed complex social structures, leadership hierarchies, and shared histories that rivaled any physical organization. Players would spend hours each day in these virtual worlds, forming friendships and rivalries that felt as real as any offline relationship. By the mid-1990s, the World Wide Web was beginning to transform online communities once again. Web-based forums and discussion boards made online communities more accessible and visually appealing. The ability to include images, links, and multimedia content enriched online discussions and made them more engaging. Personal home pages allowed individuals to express their identities and interests in new ways, creating the first primitive forms of social media profiles. The late 1990s saw the emergence of specialized online communities around virtually every conceivable interest. There were communities for fans of specific TV shows, musicians, or books, professional communities for people in specific industries or careers, geographic communities for people living in specific cities or regions, hobby communities for collectors, crafters, and enthusiasts of every stripe. The internet was becoming a vast archipelago of interest-based tribes, each with its own culture and customs. But perhaps the most important development was the realization that online communities could have real-world impact. Online organizing, led to offline meetups, conventions, and events. Internet communities raised money for charitable causes, provided support during crises, and even influenced political outcomes. The line between online and offline life was beginning to blur as digital relationships became as meaningful and consequential as physical ones. By 1999, online communities had evolved from a curiosity for computer enthusiasts to a fundamental part of how millions of people socialized, learned, and found meaning in their lives. The internet had proven that human beings' need for community and connection was so strong that they would create new forms of social organization using whatever tools were available, even if those tools were primitive, slow, and required them to type everything they wanted to say. The stage was set for the next evolution of online community, social networking sites that would make it easier than ever to connect with others, but would also raise new questions about privacy, authenticity, and the nature of friendship itself. The internet had taught us that we could be social creatures in digital spaces, but it hadn't yet taught us how to be human in a world where the boundaries between public and private, online and offline, friend and stranger were constantly shifting. The online communities of the 1980s and 1990s were like the first settlements in a new frontier, rough, experimental, but full of pioneers who were willing to try new ways of being human together. They laid the foundation for the social internet we inhabit today, for better and for worse. March 10th, 2000. The Nasdaq Composite Index hit the value of 5,048.62, its all-time high, and for a brief shining moment, it seemed like the internet had indeed changed everything. Companies with no profits were worth billions. 20-something CEOs were gracing magazine covers. Venture capitalists were throwing money at any business plan that included the words .com or e-commerce. The new economy had arrived, and the old rules of business, things like revenue and profit, were apparently as obsolete as typewriters and rotary phones. Then reality called, and it wanted its money back. What happened next was one of the most spectacular financial collapses in history, a crash so complete and devastating that it would take years for people to trust internet companies again. But like all great crashes, this one didn't happen overnight. It was the result of years of increasingly irrational behavior, wishful thinking, and the collective delusion that the laws of economics had been suspended by the power of fiber optic cables and HTML code. To understand how spectacular the crash was, you need to understand how ridiculous the boom had become. By early 2000, the internet economy had created a parallel universe where normal business logic didn't apply. Companies were valued not on their profits, most had none, or even their revenue, many had very little, but on metrics like eyeballs, page views, and mindshare. It was like valuing restaurants based on how many people walked past them on the sidewalk, regardless of whether anyone ever came inside or ordered food. The poster child for this insanity was a company called Pets.com, which sold pet supplies online and was famous for its sock puppet mascot that appeared in Super Bowl commercials. Pets.com went public in February 2000 with a market capitalization of $290 million, despite having lost $61.8 million on revenues of just $5.8 million the previous year. The company was essentially paying customers to buy its products. They were losing money on every sale and trying to make it up in volume. It was like a restaurant that charged $5 for a $10 meal and hoped to become profitable by serving more customers. But Pets.com wasn't unique, it was typical. Webvan, an online grocery delivery service, raised $800 million and built a network of high-tech warehouses before discovering that most people were perfectly happy buying their own groceries. eToys raised $166 million and competed directly with Toys R Us, except without the advantage of physical stores, established supplier relationships, or a clear path to profitability. Cosmo.com promised to deliver anything from ice cream to DVDs within an hour, for free, in major cities, a business model that worked great until someone did the math on delivery costs. The venture capital community had completely lost its collective mind. VCs were funding companies based on PowerPoint presentations and the charisma of their founders, with minimal due diligence or business analysis. The fear of missing out on the next Amazon was so intense that investors were throwing money at any company that could spell internet. It was like a gold rush where people were so excited about finding gold that they forgot to check whether they were actually digging in the right place. The media coverage of the dot-com boom was breathlessly positive and largely uncritical. Business magazines featured cover stories about the new economy and the death of distance. Television shows profiled internet entrepreneurs as if they were rock stars. Traditional business metrics were dismissed as old economy thinking. Anyone who questioned whether companies with no profits could really be worth billions was labeled a dinosaur who didn't get it. The psychological atmosphere was intoxicating. Everyone knew someone who had become a millionaire by joining the right startup at the right time. College students were dropping out to start internet companies. Established professionals were leaving secure jobs for stock options in companies that existed only as websites and business plans. The fear of missing out was so intense that rational decision-making became almost impossible. But underneath all the hype and speculation, some uncomfortable truths were becoming apparent to anyone who was paying attention. Most dot-com companies were burning through cash at unsustainable rates. Customer acquisition costs were often higher than customer lifetime value. The infrastructure costs of running internet businesses were much higher than anyone had anticipated. And most importantly, many of these companies were solving problems that didn't actually exist or weren't worth solving. The first cracks in the facade appeared in late 1999 and early 2000. Several high-profile IPOs performed poorly, with stock prices falling immediately after going public. Some dot-com companies began running out of money and shutting down. Venture capitalists started asking harder questions about business models and paths to profitability. The phrase burn rate, how quickly a company was spending its cash, became a common topic of conversation in Silicon Valley. The crash when it came was swift and merciless. The Nasdaq, which had been dominated by technology stocks, began falling in March 2000 and didn't stop falling for 2 years. By October 2002, it had lost 78% of its value from its peak. Hundreds of dot-com companies went out of business. Thousands of people lost their jobs. Billions of dollars in investment capital simply evaporated. The human cost was enormous. Employees who had been paid partly in stock options watched their paper wealth disappear overnight. Many had turned down higher-paying jobs at established companies in favor of the potential riches of startup equity. Now they found themselves unemployed, with worthless stock certificates and resumes full of companies that no longer existed. It was like waking up from a dream to discover that your lottery ticket was actually a grocery receipt. The psychological impact was even more devastating than the financial losses. The dot-com boom had created a culture of optimism and possibility that made anything seem achievable. The crash replaced that optimism with cynicism and doubt. People who had believed they were building the future discovered they had been participating in a massive speculative bubble. The internet, which had seemed like a magical solution to every business problem, was suddenly viewed with suspicion and skepticism. But the crash also served an important function. It separated the companies that were building real businesses from those that were just riding the wave of investor enthusiasm. Amazon, which had been dismissed by many as just another overvalued dot-com, survived the crash and emerged stronger. eBay continued to grow and eventually became profitable. Google, which had been founded in 1998 but hadn't yet gone public, used the crash as an opportunity to build its business without the distraction of inflated expectations. The dot-com crash also forced a return to business fundamentals. Companies that survived had to focus on revenue, profit margins, and sustainable business models. The era of growth at any cost was over, replaced by a more mature understanding of what it takes to build a successful internet business. It was like the end of adolescence, painful but necessary for healthy development. The infrastructure that had been built during the boom didn't disappear when the bubble burst. The fiber optic cables, data centers, and software platforms that had been funded by dot-com investments became the foundation for the next generation of internet companies. The crash had cleared away the speculative excess, but it had left behind the tools and technologies that would power the internet's next phase of growth. By 2001, the internet had grown up. The wild optimism of the boom years was gone, replaced by a more realistic understanding of both the opportunities and limitations of online business. The companies that survived the crash were leaner, more focused, and more sustainable than their predecessors. They had learned that the internet was a powerful tool, but it wasn't magic. It still required good business fundamentals, satisfied customers, and eventually profits. The dot-com crash was a painful but necessary correction that taught the internet industry some crucial lessons. It showed that technology alone wasn't enough to guarantee business success. It demonstrated that customer acquisition and retention were harder and more expensive than anyone had anticipated. Most importantly, it proved that the internet was subject to the same economic laws as every other industry. Companies that didn't create real value for real customers would eventually fail, no matter how impressive their technology or how charismatic their founders. The crash also marked the end of the internet's childhood. The web was no longer a playground for experimenters and dreamers. It was a mature medium that required serious business thinking and disciplined execution. The companies that would dominate the next phase of internet development would be those that combined technological innovation with sound business practices, customer focus, and financial discipline. The party was over, but the real work was just beginning. Remember dial-up internet? Of course you don't, because your brain has mercifully blocked out the trauma of waiting 17 minutes for a single photograph to load, one pixelated line at a time. You've forgotten the distinctive screech of a modem connecting, the agonizing choice between using the phone and checking email, and the special kind of rage that came from being disconnected just as a large file was about to finish downloading. But for those of us who lived through the dial-up era, the arrival of broadband internet wasn't just a technological upgrade. It was like discovering fire, inventing the wheel, and learning to fly all at the same time. This is the story of how the internet stopped being something you went on and became something you lived in. In 1999, most Americans connected to the internet the same way their grandparents had made long-distance phone calls, carefully, briefly, and with constant awareness of the cost. Dial-up internet was like having a conversation through a straw while someone played a kazoo in the background. At 56 kilobits per second, downloading a single song took about 15 minutes. Watching a video online was theoretically possible, but practically masochistic. The dial-up experience shaped how people used the internet in fundamental ways. You planned your online sessions like military operations. You'd queue up your email downloads, start a file transfer, and then go make coffee while praying that your connection wouldn't drop. Websites were designed with dial-up users in mind, which meant minimal graphics, tiny images, and lots of text. The internet was a place you visited, not a place you lived. But change was coming, and it was coming fast. Cable companies, which had spent decades running coaxial cables into American homes to deliver television, suddenly realized they could use those same cables to deliver internet service at speeds that made dial-up look like smoke signals. Meanwhile, telephone companies were upgrading their infrastructure with DSL, or digital subscriber line, technology that could deliver broadband speeds over existing phone lines. The first broadband connections were revelatory. Suddenly web pages loaded instantly. Images appeared in seconds rather than minutes. You could actually watch video clips without planning your day around them. Most importantly, you could stay connected all the time without tying up your phone line or paying by the minute. It was like upgrading from a horse and buggy to a Ferrari, except the Ferrari was also a time machine that gave you access to all human knowledge. But the real transformation wasn't just about speed, it was about the psychological shift from scarcity to abundance. Dial-up internet had trained users to be conservative, to think carefully about every click and every download. Broadband internet encouraged exploration, experimentation, and casual browsing. You could follow link after link without worrying about connection time. You could leave multiple browser windows open. You could actually use the internet for entertainment rather than just information gathering. The adoption of broadband followed a predictable pattern. Early adopters paid premium prices for the privilege of being first. Then prices dropped, and speeds increased as competition intensified and infrastructure improved. By 2000, about 5% of American households had broadband. By 2005, that number had grown to over 40%. The tipping point came when broadband became cheaper and more convenient than dial-up, at which point the migration became an avalanche. The impact on web design and content was immediate and dramatic. Websites that had been constrained by dial-up limitations suddenly bloomed with rich graphics, multimedia content, and interactive features. Flash animations became ubiquitous and annoying. Online video went from a curiosity to a standard feature. E-commerce sites could display high-resolution product photos and virtual tours. The web was transforming from a text-based medium into a multimedia experience. But perhaps the most significant change was cultural. Broadband internet enabled the always-on lifestyle that we now take for granted. Instead of going online for specific tasks, people began to live online. Email checking became a constant background activity. Instant messaging allowed for ongoing conversations throughout the day. Online gaming became a social activity that could last for hours. The internet was no longer a tool you used, it was an environment you inhabited. The always-on internet also changed how we consumed news and information. Instead of waiting for the morning newspaper or the evening news broadcast, people could get updates continuously throughout the day. News websites began updating their content in real time. Blogs emerged as a new form of personal publishing that could be updated instantly and read immediately. The 24-hour news cycle became a reality, not just for professional journalists, but for anyone with an internet connection and an opinion. Online entertainment exploded with the arrival of broadband. Streaming audio services like Real Audio and later iTunes made it possible to listen to music without downloading files. Online gaming evolved from simple text-based adventures to complex multiplayer worlds with sophisticated graphics and real-time interaction. Video sharing sites began to emerge, though it would take a few more years for YouTube to perfect the formula. The business implications were enormous. Companies that had been constrained by dial-up limitations could suddenly offer rich interactive experiences to their customers. Software companies began delivering updates and patches over the internet, rather than through physical media. The concept of software as a service became viable when applications could be delivered through web browsers rather than installed on individual computers. Broadband also enabled new forms of communication and collaboration. Video conferencing, which had been an expensive luxury for large corporations, became accessible to small businesses and even individuals. File sharing became practical for large documents and multimedia files. Remote work became more feasible when employees could access company networks and applications from home with reasonable performance. The social implications were equally profound. Online communities that had been limited to text-based communication could suddenly incorporate voice, video, and multimedia content. Dating sites could include photo galleries and video profiles. Social networking sites could support photo sharing and multimedia messaging. The internet was becoming a more human, more personal medium. But broadband also created new problems and challenges. The always-on internet made it easier to waste time online. Internet addiction became a recognized phenomenon as people found themselves unable to disconnect from the constant stream of information and entertainment. Privacy concerns increased as companies could track user behavior more comprehensively. The digital divide between those with broadband access and those without became more pronounced. The transformation from dial-up to broadband also marked a shift in how we thought about the internet's role in society. During the dial-up era, the internet was seen as a supplement to real life, a useful tool for specific tasks like research, communication, and shopping. With broadband, the internet began to compete with real life as a place where people spent significant portions of their time and attention. By 2005, broadband internet had become the standard for most American households and businesses. The dial-up era was ending, and with it, the internet's awkward adolescence. The web was no longer a slow, limited, frustrating experience that required patience and planning. It was becoming a fast, rich, immersive medium that could support any kind of content or application that developers could imagine. The always-on internet enabled by broadband laid the foundation for everything that would follow: social media, streaming video, cloud computing, mobile internet, and the Internet of Things. It made possible the connected world we now inhabit, where being offline feels abnormal, and being unable to access information instantly feels like a disability. The transition from dial-up to broadband was more than just a technological upgrade. It was a fundamental shift in how humans related to information, entertainment, and each other. It marked the moment when the internet stopped being a destination and became a way of life. We had crossed the threshold into the always connected world, and there would be no going back. The internet had finally become fast enough to keep up with human impatience, and that changed everything. In 2003, if you wanted to share your thoughts with the world, you had limited options. You could write a letter to the editor of your local newspaper and hope they'd print it. You could start a blog and hope someone would read it. You could call into a radio talk show and hope you wouldn't sound like an idiot on the air. Or you could just keep your opinions to yourself, like most people had done for most of human history. Then along came a Harvard sophomore named Mark Zuckerberg, who looked at the internet and thought, you know what this needs? A way for college students to rate each other's attractiveness and share way too much personal information. He probably didn't realize he was about to accidentally create the most addictive, influential, and controversial communication medium in human history. But then again, most revolutions start with someone trying to solve a much smaller problem. This is the story of how social media transformed the internet from a place you visited into a place you lived, and how it changed not just how we communicate, but how we think, feel, and understand ourselves and each other. The prehistory of social media stretches back to the early online communities we discussed earlier. Bulletin board systems, chat rooms, and forums where people gathered around shared interests. But these early communities were like small towns where everyone knew everyone else, or at least knew their screen names. Social media would be different. It would be like living in a city of billions, where everyone was simultaneously your neighbor and a complete stranger. The first recognizable social media platform was Friendster, launched in 2002 by Jonathan Abrams. Friendster was based on a simple but revolutionary idea. What if you could map your real-world social connections online? Instead of meeting strangers in chat rooms or forums, you could connect with people you actually knew, and through them, meet their friends. It was like having a digital version of your social circle, except it could grow infinitely and never forget anyone's birthday. Friendster was followed by MySpace in 2003, which took the social networking concept and added a crucial ingredient: self-expression. MySpace allowed users to customize their profiles with colors, music, and graphics, turning each profile into a personal homepage that reflected the user's personality and interests. Suddenly, your online presence wasn't just about who you knew, it was about who you were, or at least who you wanted people to think you were. MySpace became the first truly massive social media platform, reaching 100 million users by 2006. It was particularly popular with musicians and artists, who used it to share their work and build fan bases. For the first time, creative people could bypass traditional gatekeepers like record labels and galleries to reach audiences directly. It was like giving everyone their own radio station, record label, and art gallery all at once. But MySpace's success also revealed some of the challenges that would plague social media for years to come. Profiles became increasingly cluttered and chaotic, as users tried to cram more and more content onto their pages. The platform struggled with spam, fake profiles, and inappropriate content. Most importantly, MySpace discovered that managing a community of millions of users was like trying to moderate a conversation between everyone in New York City while they were all talking at the same time. Enter Facebook, which launched in 2004 as the Facebook, a social networking site exclusively for college students. Zuckerberg's genius wasn't in inventing social networking, as Friendster and MySpace had already done that, but in understanding that exclusivity could be more powerful than openness. By limiting access to college students with verified edu email addresses, Facebook created a sense of prestige and authenticity that its competitors lacked. Facebook's design was also revolutionary in its simplicity. While MySpace profiles looked like digital collages created by hyperactive teenagers, Facebook profiles were clean, standardized, and focused on real information about real people. The platform emphasized authentic identity over creative expression, real names over screen names, and actual relationships over random connections. It was like the difference between a house party and a nightclub: more intimate, more personal, and ultimately more addictive. The expansion of Facebook beyond college campuses was gradual but inexorable. First to high schools, then to workplaces, and finally to everyone. Each expansion brought new users and new use cases, but it also diluted the exclusivity that had made Facebook special in the first place. By 2006, Facebook was competing directly with MySpace for mainstream users, and the battle for social media dominance was on. Meanwhile, other platforms were exploring different aspects of social sharing. LinkedIn, launched in 2003, focused on professional networking and career development. YouTube, launched in 2005, made video sharing accessible to everyone with a camera and an internet connection. Twitter, launched in 2006, reduced social sharing to its essence: 140-character messages that answered the question, "What are you doing?" Each platform developed its own culture and conventions. Facebook became the place for sharing life updates with friends and family. MySpace remained the platform of choice for musicians and artists. LinkedIn was for professional networking and job searching. YouTube was for entertainment and education. Twitter was for news, opinions, and real-time commentary on current events. But the real revolution wasn't in any single platform. It was in the collective impact of social media on human behavior and society. For the first time in history, ordinary people had access to broadcasting tools that could potentially reach millions of others. Everyone became their own media company, with the power to publish, broadcast, and influence others on a scale that had previously been limited to major corporations and institutions. The psychological impact was profound. Social media tapped into fundamental human needs for connection, validation, and self-expression, but it also created new forms of anxiety, comparison, and addiction. The constant stream of updates from friends and acquaintances created a fear of missing out, known as FOMO, that made it difficult to disconnect. The ability to curate and edit your online presence created pressure to present a perfect version of your life that might bear little resemblance to reality. Social media also changed how we consume and share information. News and opinions spread through social networks faster than through traditional media channels. Viral content could reach millions of people in hours or days, creating shared cultural experiences that transcended geographic and demographic boundaries. But the same mechanisms that could spread important information could also spread misinformation, rumors, and propaganda. The business implications were enormous. Companies discovered that social media could be a powerful marketing tool, allowing them to reach customers directly and build brand loyalty through engagement and interaction. Influencer marketing emerged as people with large social media followings could command significant fees for promoting products and services. The attention economy was born, where the ability to capture and hold people's attention became the most valuable commodity. By 2010, social media had become an integral part of daily life for hundreds of millions of people around the world. Facebook had over 500 million users. Twitter was being used to organize political movements and share breaking news. YouTube was launching careers and creating new forms of entertainment. The internet had evolved from a tool for accessing information to a platform for sharing experiences, opinions, and identities. But social media's rapid growth also created new challenges and controversies. Privacy concerns mounted as platforms collected vast amounts of personal data and made it available to advertisers and third parties. Cyberbullying became a serious problem as the anonymity and distance of online communication enabled harassment and abuse. The addictive nature of social media began to raise questions about its impact on mental health, particularly among young people. The social media revolution of the 2000s fundamentally changed the internet and society. It democratized publishing and broadcasting, giving everyone a voice and a platform. It created new forms of community and connection that transcended geographic boundaries. It enabled new business models and economic opportunities. But it also created new problems and challenges that we're still grappling with today. Social media proved that the internet's greatest power wasn't in connecting computers, it was in connecting people. But as we would soon discover, connecting everyone to everyone else would have consequences that nobody had anticipated, and solutions that nobody had prepared for. The social media revolution had given humanity a new superpower, but like all superpowers, it came with great responsibility that we were still learning how to handle. The age of social media had begun, and the world would never be the same. June 29, 2007. While most of America was debating whether the iPhone was worth $599 and wondering if anyone really needed internet access on their phone, Steve Jobs was about to accidentally solve a problem that nobody knew they had, being disconnected from the internet for more than 5 minutes at a time. The iPhone wasn't just a phone with internet access, it was the internet with phone capabilities attached. And once the internet learned how to fit in your pocket, it would never go back to living on your desk. This is the story of how the internet broke free from the tyranny of keyboards, mice, and Ethernet cables, and how humanity discovered that having unlimited access to all human knowledge was less important than being able to check Instagram while waiting in line for coffee. But let's back up for a moment and appreciate just how revolutionary the concept of mobile internet was. In 2007, going online still meant sitting down at a computer, waiting for it to boot up, connecting to the internet, and then navigating to websites using a keyboard and mouse. The internet was a destination, a place you went when you needed to accomplish specific tasks, like checking email, researching something, or buying products online. Mobile phones existed, of course, but they were primarily communication devices. You could make calls, send text messages, and if you were really adventurous, You could access a stripped-down version of the internet through something called WAP, the Wireless Application Protocol, which was like trying to browse the web through a keyhole while wearing oven mitts. The experience was so frustrating that most people didn't bother. The iPhone changed everything by making mobile internet access not just possible, but actually enjoyable. The touchscreen interface eliminated the need for a physical keyboard. The Safari browser could display actual websites, not mobile-specific versions that looked like they'd been designed by someone who had only heard websites described secondhand. Most importantly, the iPhone made internet access feel natural and intuitive rather than like a technical challenge that required a computer science degree. But the real genius of the iPhone wasn't in its hardware, it was in its software ecosystem. The App Store, launched in 2008, created a new category of software designed specifically for mobile devices. Instead of trying to cram desktop applications onto small screens, developers began creating apps that took advantage of the unique capabilities of mobile devices, location awareness, camera access, touch interfaces, and always-on connectivity. The early iPhone apps were charmingly simple by today's standards. There was a flashlight app that turned your screen white, a level app that used the phone's accelerometer to help you hang pictures straight, a fart noise app that, well, made fart noises. But even these simple apps demonstrated something profound. Mobile devices weren't just smaller computers, they were entirely new platforms with their own possibilities and limitations. The competition responded quickly. Google launched Android in 2008, creating an open-source alternative to iOS that could be used by any manufacturer. BlackBerry, which had dominated the business smartphone market, scrambled to add consumer-friendly features. Microsoft, Nokia, and Palm all launched their own smartphone platforms, each trying to capture a piece of the rapidly expanding mobile internet market. But the real transformation wasn't in the technology, it was in human behavior. Smartphones made the internet ambient, always present in the background of daily life. You could check your email while walking down the street, look up restaurant reviews while standing outside the restaurant, or settle arguments about movie trivia in real time during conversations. The internet stopped being something you accessed and became something you inhabited. The psychological impact was immediate and profound. The smartphone created a new form of anxiety, the fear of being disconnected. Nomophobia, the fear of being without your mobile phone, became a recognized condition. People began checking their phones compulsively, often without any specific purpose in mind. The average smartphone user began checking their device over 100 times per day, turning internet access from an occasional activity into a constant compulsion. Mobile internet also changed how we navigate the physical world. GPS navigation apps made it possible to travel anywhere without getting lost. Location-based services could recommend nearby restaurants, shops, and attractions. Ride-sharing apps like Uber and Lyft used mobile internet to create entirely new transportation systems. The boundary between digital and physical space began to blur as mobile devices became our interface to both worlds. Social media evolved rapidly to take advantage of mobile capabilities. Facebook redesigned its interface for small screens and touch navigation. Twitter's 140-character limit, which had seemed arbitrary on desktop computers, made perfect sense on mobile devices where typing was more difficult. Instagram, launched in 2010, was designed from the ground up for mobile photo sharing, turning everyone into a photographer and curator of their own visual narrative. The rise of mobile internet also democratized access to information and services in unprecedented ways. In developing countries where desktop computers and broadband internet were expensive luxuries, smartphones provided affordable access to the global internet. Mobile banking allowed people without traditional bank accounts to participate in the digital economy. Educational apps made learning resources available to anyone with a smartphone and an internet connection. But mobile internet also created new challenges and problems. The small screen size made it difficult to consume complex information or perform detailed tasks. The touch interface, while intuitive for simple interactions, was frustrating for text input or precise control. Battery life became a constant concern as power-hungry apps and always-on connectivity drained devices quickly. Privacy and security concerns multiplied as smartphones collected unprecedented amounts of personal data. Location tracking, contact lists, photos, messages, and browsing history created detailed profiles of users' lives and behaviors. App developers and advertising companies began using this data to target users with personalized content and advertisements, raising questions about consent, privacy, and the commodification of personal information. The mobile internet also changed the economics of the web. Desktop websites, which had been designed for large screens and precise mouse control, needed to be redesigned for mobile devices. Responsive design became essential as web developers learned to create sites that worked well on screens of all sizes. Mobile apps created new revenue models based on in-app purchases, subscriptions, and mobile advertising. By 2010, mobile internet usage was growing exponentially. Smartphones were becoming more powerful, networks were getting faster, and apps were becoming more sophisticated. The mobile internet was no longer a novelty. It was becoming the primary way that many people accessed online services and information. The introduction of tablets, led by the iPad in 2010, created a new category of mobile devices that bridged the gap between smartphones and laptops. Tablets offered larger screens for content consumption while maintaining the touch interface and portability of smartphones. They became popular for reading, gaming, and media consumption, further expanding the mobile internet ecosystem. Social and cultural changes accelerated as mobile internet became ubiquitous. Continuous partial attention became the norm as people learned to multitask between physical and digital activities. Public spaces filled with people staring at their phones instead of interacting with each other. Hubbing, ignoring someone in favor of your phone, became a recognized social problem. But mobile internet also enabled new forms of creativity and expression. Mobile photography apps turned everyone into a potential artist. Video sharing apps like Vine, and later TikTok, created new forms of entertainment and communication. Podcasting became accessible to anyone with a smartphone and something to say. The barriers to content creation continued to fall as mobile devices became more powerful and user-friendly. By 2015, mobile internet usage had surpassed desktop usage in many countries. The smartphone had become the primary computing device for billions of people around the world. The internet was no longer tethered to desks and offices. It was everywhere all the time, in everyone's pocket. The mobile internet revolution transformed not just how we access information, but how we live our lives. It made the internet truly ubiquitous, turning it from a tool we used into an environment we inhabited. It created new possibilities for communication, commerce, and creativity, but it also created new dependencies, anxieties, and social problems. Most importantly, mobile internet completed the transformation of the internet from a network of computers into a network of people. Every smartphone became a node in a global communication system that connected billions of individuals in real time. The internet had finally achieved its ultimate form, not as a destination we visited, but as a medium we lived within. The age of mobile internet had arrived, and humanity would never be the same. Here we are, folks. The final chapter of our wild ride through internet history. If you've stuck with me this far, congratulations. You've just witnessed the most dramatic transformation in human communication since we figured out how to grunt meaningfully at each other around a campfire. But unlike those ancient conversations, today's internet doesn't just connect people, it connects everything. Your refrigerator is probably smarter than the computer that sent humans to the moon, and it's definitely more opinionated about your grocery choices. Let's take a moment to appreciate the sheer absurdity of where we've landed. You're likely listening to this while your phone automatically adjusts your home's temperature, your car downloads software updates, and your doorbell records video of every squirrel that dares to cross your property. We've created a world where your toaster can tweet, your watch can call an ambulance, and your vacuum cleaner maps your house with the precision of a military reconnaissance mission. If you told someone in 1969 that their coffee maker would one day have an IP address, they'd have recommended immediate psychiatric evaluation. The Internet of Things, or IoT, because we love our acronyms, has turned every device into a potential Internet citizen. We're talking about 50 billion connected devices by 2030, which means there will soon be more Internet-connected objects than there are neurons in the human brain. Your smart home isn't just convenient, it's essentially a digital nervous system that knows when you wake up, what you eat, and probably judges your Netflix choices. It's like having a very polite, very efficient stalker who also controls your thermostat. But let's talk about the elephant in the digital room: artificial intelligence. The internet has become the training ground for AI systems that can write poetry, diagnose diseases, and beat humans at games we invented to prove our intellectual superiority. ChatGPT and its AI cousins have consumed virtually the entire internet, digesting everything from Shakespeare to your embarrassing teenage blog posts. They've learned to mimic human conversation so well that we're now having philosophical debates about whether they're actually thinking or just very sophisticated parrots with access to Wikipedia. The implications are staggering. We've created machines that can generate art, write code, and compose music by learning from the collective creativity of humanity. It's like we've built a digital apprentice that watched every master at work and can now create in any style imaginable. The internet, which started as a way to share research papers, has become the world's largest training dataset for artificial minds. Your cat videos aren't just entertainment anymore, they're teaching materials for the next generation of AI. Social media, meanwhile, has evolved into something that would make Orwell's Big Brother seem like an amateur. We willingly carry devices that track our every movement, record our conversations, and analyze our behavior patterns. But instead of feeling oppressed, we feel connected. We share our breakfast choices with strangers, live stream our daily routines, and create digital personas that are often more polished than our real selves. It's voluntary surveillance disguised as social networking, and we can't get enough of it. The pandemic of 2020 proved just how essential the internet has become. When the physical world shut down, the digital world kept civilization running. Suddenly, your grandmother was video calling from her iPad, your 5-year-old was attending school through Zoom, and your local restaurant was surviving on delivery apps. The internet wasn't just a convenience anymore, it was life support for society. We discovered that human connection could survive physical separation, as long as we had bandwidth. Remote work transformed from a rare perk to a fundamental right. Companies that had spent decades insisting that productivity required physical presence suddenly discovered that their employees could be just as effective in pajama pants. The internet had finally fulfilled its promise of making geography irrelevant. You could live in a cabin in Montana and work for a company in Manhattan, as long as you had a decent Wi-Fi connection and the ability to mute yourself during video calls. But with great connectivity comes great responsibility and great vulnerability. Cybersecurity has become as important as physical security, maybe more so. Your digital identity is worth more to criminals than your wallet. Data breaches expose millions of personal records with alarming regularity, and ransomware attacks can shut down entire cities. We've created a world where a teenager in their bedroom can potentially disrupt global infrastructure, and where nation-states wage war through keyboards rather than missiles. Privacy has become the internet's most precious commodity. We're constantly negotiating the trade-off between convenience and confidentiality. Every app wants access to your location, your contacts, your photos, and your deepest secrets. We click accept on terms of service agreements longer than most novels, essentially signing away our digital souls for the privilege of using free services. It's the devil's bargain of the digital age, unlimited access to information and entertainment in exchange for unlimited access to you. The environmental impact of our digital addiction is staggering. The internet now consumes about 4% of global electricity, and that number is growing faster than renewable energy can keep up. Every Google search, every Netflix stream, every TikTok video contributes to carbon emissions. We've created a virtual world that has very real consequences for our physical planet. The cloud isn't actually in the sky, it's in massive data centers that consume more power than entire countries. Yet despite all these challenges, the internet continues to democratize opportunity in unprecedented ways. A kid with a smartphone in rural Kenya has access to the same educational resources as a student at Harvard. Artists can build global audiences without gallery representation. Entrepreneurs can start businesses without venture capital. The internet has flattened hierarchies and eliminated gatekeepers in ways that would have been unimaginable just decades ago. Cryptocurrency and blockchain technology promise to decentralize not just information but value itself. We're experimenting with digital currencies that exist independently of governments, smart contracts that execute automatically, and virtual worlds where digital real estate sells for millions of real dollars. It's either the future of finance or the world's most elaborate Ponzi scheme, possibly both. The metaverse, that buzzword-heavy vision of virtual reality social spaces, represents the internet's next evolutionary leap. Instead of looking at screens, we'll inhabit digital worlds. Instead of typing messages, we'll have virtual conversations. Instead of watching videos, we'll experience stories. It's the ultimate merger of physical and digital reality, where the line between real and virtual becomes meaningless. But perhaps the most remarkable thing about today's internet is how unremarkable it has become. We carry supercomputers in our pockets and think nothing of it. We video call people on the other side of the planet as casually as we once called the house next door. We access the sum of human knowledge with a few taps and get annoyed when it takes more than 3 seconds to load. We've become so accustomed to digital miracles that we only notice them when they stop working. The internet has rewired not just our technology, but our brains. We think in hyperlinks, communicate in memes, and measure attention in seconds rather than minutes. We've developed the ability to process multiple streams of information simultaneously while losing the capacity for deep, sustained focus. We're more connected than ever before, yet loneliness has become an epidemic. We have access to infinite entertainment, yet boredom persists. We can fact-check anything instantly, yet misinformation spreads faster than truth. As we stand at this digital crossroads, we face questions that would have seemed like science fiction just a generation ago. Should AI have rights? Can virtual relationships be as meaningful as physical ones? Who owns the data that defines our digital selves? How do we maintain human agency in an increasingly automated world? These aren't just technical questions, they're fundamental questions about what it means to be human in a connected age. The internet that began as a military research project has become humanity's nervous system. It carries our thoughts, our dreams, our fears, and our hopes across vast distances at the speed of light. It has made us more powerful and more vulnerable, more informed and more confused, more connected and more isolated than ever before. So where do we go from here? The internet story is far from over. We're probably still in the opening chapters of a much longer tale. Quantum computing promises to make today's fastest processors look like pocket calculators. Brain-computer interfaces might eliminate the need for screens altogether. Space-based internet could bring connectivity to every corner of the solar system. But whatever comes next, remember this: the internet isn't just a technology, It's a mirror that reflects our collective humanity. Every website, every app, every digital interaction is a testament to our fundamental desire to connect, to share, to understand and be understood. From ARPANET's first message to today's global digital ecosystem, the internet has always been about bringing people together, even when we're physically apart. The future of the internet is the future of humanity itself. It will be shaped not by algorithms or corporations or governments, but by billions of individual choices made by people like you. Every click, every share, every digital interaction is a vote for the kind of connected world we want to live in. So as we close this chapter of internet history, remember that you're not just a user or a consumer, you're a participant in the greatest communication revolution in human history. The internet's next chapter is waiting to be written, and you hold the keyboard. The story continues, one connection at a time. Thank you for joining me on this journey through the history of the internet. From the first tentative connections between university computers to today's globally connected world, we've witnessed the transformation of human communication itself. The internet isn't just a technology, it's the story of our species learning to think, dream, and create together on a planetary scale. What started as a solution to a Cold War communication problem has become the foundation of modern civilization. And the most amazing part, we're just getting started. Keep exploring, keep connecting, and remember, every time you go online, you're participating in the greatest collaborative project in human history. Until next time, this is your guide through the digital frontier, signing off from the ever-expanding universe we call the internet.